my greeting number 2. As I was saying, hello everybody. It's welcome to the Keshe Plasma Reactor Group for Tuesday, November 8th, 2016. And I just saw a picture of Willie's picture with a looks like a GANs container over his head, and I think that's what's being broadcast right now, because I don't have my picture pinned on the second screen yet. That was kind of funny. All right. You'll definitely have to explain that. It's a CO2 container. Okay. And the question is, does it? Pardon me?
And I used it for CH3 later.
On your head, you mean?
No, I was using it for making CH3 GANs and CO2.
So the big question is, did it work when it was on your head?
It doesn't seem like it, but
It was no effect? I think you must have at least had fun with your reactor.
Yeah, I did.
That's rule number 1 that Mr. Keshe says. He says you must pray to your reactor, and he says when I pray to my reactors every time I start them up, and it could be 100 times a day, he said, I hope you're going to have as much fun with this as I am. And that's his little prayer that he says to his reactor friends, the entities in the reactors. So
certainly got a couple of laughs of it.
Yeah. Well, it's good that you're brave enough to put it on as your picture and aren't holding back on the technology. It's a good way to advertise, I suppose. What is that thing in your head? Well, now that you mention it, you could start a new style in hats. You know, I'm wearing a toque, but I could be just as easily wearing a plastic box. Speaking of plastic boxes, that was a good segue. I'd like to introduce my new reactor, the plastic box. It's actually a reactor in a box, you could say. Let me just zero in a bit here. So I'm just getting this together today, so it's a work in progress. But basically, the way it's set up is I've got a sphere inside here, which very easily detaches. It's got a nice big opening, so that I can also put a second sphere inside, perhaps one like this size, so it'll be inside like that. And I haven't got the second shaft set up yet, but it's close. What I do have is, this is a hypodermic needle with a long, less pointy, a blunt end, but a long needle on it. And this happens to be a hollow shaft motor here. It's from a get a closer look on that. It's from a hobby motor for model airplanes. And it's a brushless 3-pole motor, hooks up to electronic speed control and so on, which I'm in the middle of getting together. And this is called an outrigger motor, which the motor housing rotates. Okay, and although the motor housing rotates, I can put the needle. It's got a hollow shaft. This is a special motor with a hollow shaft, so I'll show you here. I can hold the hypodermic needle and still rotate. The motor can rotate while this is in there, and you can see where it comes out in the bottom there. So I'll be able to inject fluids into the rotating vessel while it's rotating. That's the idea. And so yeah, I'm just getting that rigged up. I finally got an easy way to mount the top, because that was a challenge. It's always a challenge. How do you mount your parts? Like here's a top here, for example. How do you mount this onto a motor or a shaft? And that's always a challenge. And so it was pretty basic though. I had a shaft, and I should show it because everybody will be interested, no doubt. Or not, sorry, I shouldn't say that. Not everybody will be interested, but perhaps a very few will be interested, but those who do might need to know. I've been on. Part of all this is the struggle to make things simple so that we don't have to have complicated machining and whatnot to put things together. So I'll show the parts. So the inside here, there's the motor shaft that we can see there. It actually rotates, and that's the hollow shaft inside there. I don't know if you can see that actually rotating, but yeah, there it is. Okay, so this fitting fits over that shaft, and I've drilled it out so it's hollow so the needle can go all the way through. So it just fits on the shaft. It's a type of fitting that you can see the little slots cut in there. Well, when this second part slips on like this, then when the threads are tightened up here, it pulls on this collar, and the collar squishes the shaft because of the slots. The slots close up around the shaft, and this actually holds it onto the shaft. So I just slip that on. And put it on the collar. I can't hold it there. And now show the other parts. It's basically just 2 washers like this, and there's standard quarter inch hole size fender washers, they're called. And then finally, it's just this piece here that screws on the end of the shaft, and that puts pressure on the collar and squishes everything together. So the idea is the collar, it goes quite quickly. The collar goes on, the washer, the lid that I just drilled a 1/4 inch hole in. I centered it, of course, the best I could. And then the whole thing just screws together, and bingo, it's on. And if it's a little bit out around, I left enough room, just for a little bit of wiggle room on the hole, to be able to get it centered properly. I haven't done that right now, but I can do that by fiddling with it a bit. And basically, it's ready to go. And I've got a spinning reactor. Now these globes are interesting. It's hard to find materials that work properly with spinning reactors. They can get actually quite dangerous at times because of the spin factor and so on. But a lot of people are using these acrylic balls, like this little one I showed here. This is a 2-piece, quite nicely made, very precise and so on. It's made sort of for Christmas ornaments, and you get them in different sizes. And it's fairly tough, you know, it's fairly tough, but it's acrylic, and acrylic will tend to fatigue, tend to crack easily, and basically when it lets go all at once, just shatters. It's not like polycarbonate where it stretches more and is 20 times tougher and so on. So these acrylic balls are not to be trusted at very high RPMs. But inside of this globe, if this is filled with liquid and this is filled with liquid, then the chances of this exploding are almost nil, probably, compared. And even if it did, it has a liquid buffer around it and so on. So this material, I'm just going to get back to that, which is, they call it an unbreakable globe, and they use it. You can make it into like a snow globe, or you can put different things inside and so on. And you know, it's pretty tough. It's not thick. I can push it in quite easily, but it is of a particular material that is quite tough. It tends to take a beating. So I'm hoping that spinning this at moderately high speeds, not at really high speeds, like maybe up to, well, 4,000 or 5,000 RPM, I'm hoping to get out of it. It's quite a bit for this radius sphere, especially filled with liquids. And I'm hoping it will self-balance in the way that liquids will tend to form their own center of gravity, and it'll basically balance itself and not destroy my little motor here bearings. And so anyways, that's a work in progress, and I'm looking forward to it. I wanted to play with this. The other feature with this is the box. I wanted to have a box around the whole apparatus because it's just too funky. There's too much of a chance of the whole thing exploding with who knows what's going to be in there. I could have an acid compound or a basic compound or different GANs that you don't really want spread all over the entire room and yourself and guests or whatever the situation is. So the idea is to contain the apparatus so that if there is any not explosion exactly, but if something goes wrong and it falls apart or breaks or cracks and there's liquid spraying out, then it's all contained within this apparatus. And the way it works is this will attach to this plate here. Okay, and this material is basically, this is bulletproof. It's polycarbonate, and that's what they make bulletproof glass out of. If this was twice the thickness, it would be technically bulletproof for anything up to army issue rounds of high caliber. Basically, bullets just bounce off. And I've done a brutal testing of this material and of this particular box. Maybe I should show I could show the video, a little short video of how I you could say pressure tested the polycarbonate. This is 3/16 inch polycarbonate. It's very, very tough stuff, and you wouldn't, I would have no problem being beside this with exploding apparatus inside. The thing about it is, acrylic sheet looks the same as polycarbonate, but acrylic will shatter, and I would not trust acrylic for anything basically as far as that goes. If you get very thick, like 1/2 inch acrylic, there's a chance it'll be pretty tough. They do use that for some vacuum chambers. But I do not recommend acrylic for any high-speed apparatus basically. I see there's a question in the chat. What is the name of the collars that tighten onto the motor pin? Is there a specific name for that type of thing? Yes, it's a I think it's it's used for a propeller. It's a propeller shaft adapter for these hobby motors. That's a good question though. Let me quickly look that up. This is a it's an E-Flight motor, and it's called a prop adapter basically. They're about maybe $12 or $8, somewhere around there. You get them for different size shafts. Prop adapter, and it's it comes with the hub nut. That's the sort of streamlined looking nut that goes on the end, and the whole it's all made of aluminum. It could be nano-coated aluminum very easily, so that's a nice feature as well. And so it's basically got this aluminum electrode sticking down into the actual spinning globe there, which is kind of interesting. And actually I could electrify that electrode by just simply putting power on this outer case of this rotating motor, and it would electrify that electrode inside. So looking forward to playing around with this thing and see what it'll do. So just so people know, these brushless motors are easy to find, but it's very difficult to find a hollow shaft brushless motor. This happens to be an E-Flight 370, and they have both the solid shaft and hollow shaft versions. So, yeah, that's basically it. I'll have this running for next week, so I can do some actual torture testing on it. Also, let me show you, speaking of torture testing, I wanted to just mention let me see, let me get it set up here. Any questions or anything while I look for a YouTube video here? Comments? Jokes? Where was it?
It looks like a pretty good idea to have your reactor in a box.
Yeah, I would
Kind of big.
highly recommend it for everybody. Actually, it's the only way to go. It's too dangerous if you're like people are going to be. When we were running at 1,000 RPM, that's one thing, or even up to 2,000. You start getting up to 10 or 15,000 RPM, which is what some people are planning on doing. It starts to get into the danger zone. That's parts can start flying apart at those speeds, and just when you don't expect it, because stress cracks can build up and that kind of thing. Let me see here. I'm just trying to find my.
Rick, it's kind of off the subject, but I'd like to show something if I can in a little while.
Yeah, okay. Let me just try to find this one video that's not showing up here. Well, go ahead, Zane. If you got something to show there, I can play around the background to try to find this video that's being elusive to me for some reason.
I got a car unit that I built, and right now I'm just I got a regular copper wire attached to both sides to see how fast it'll nano-coat. And believe it or not, it's really doing a fantastic job. It's I mean, this is how shiny the wire was, and that's only been about 20 minutes that
Did
it's been connected onto there.
did
But
you excuse me? Did you like start it with some caustic solution on the end of the wire or something like that, or is it just
no,
connected?
no,
Mm-hmm.
I just tied it on to the ends.
Mm-hmm.
And it looks like it's more nano coating in the center of it going out rather than from the ends.
Okay, well that's
But
interesting.
um on my Facebook page I showed the process that I kind of went through, to make it. But
Mm-hmm.
I don't know how to share anything on here, so I couldn't show you the inside of it and how it's set up.
Mm-hmm.
But,
Well, you could make a drawing maybe in your book there, and
well,
we could see that. Just
that's kind of it right there.
okay.
I put a CH3 spear in the center of it, and a CO2 sphere on the outside of it with some sugar in it to see if I could get the CH3 to float. But there's a coil wire, a stranded coil wire inside the middle sphere, and then I attach both sides where neither coil could either touch itself no matter what, and I put dried CH3 on the gravitational side with this contact cement that's really spectacular. And then on the magnetic side, I put the CO2 dried crystals in with the mix, and then capped it off with aluminum on both sides. And then sealed it up. And then I thought if I put the aluminum tape around it, whenever I go to put it in my truck, maybe that this would stop any of the fields coming from little motors or whatnot. But I could be wrong. Anyway, it's just a thought.
Yeah, I don't know if that would interfere with the fields or make the fields stronger. That's a good point.
Yeah, but we'll see.
Yeah, it looks pretty deadly. So, how are you going to mount it? Where are you going to mount it?
I got the spot right next to my battery, and I got this like foam padding stuff that I can wrap around it like it's sitting in a seat, and attach it to the fender wall. I got a pretty big truck. I got an F-150. It's got the V6 with the twin turbos, and the motor's not really big, but it's pretty badass.
Twin turbos.
Yeah. So we'll see what this does to it. It'd be nice if this coated the turbos, and then there was no limitations to what I could push through them. But we'll see.
Wow. Well, that'll be interesting to entrust your F-150 with twin turbos to the plasma technology.
Yeah.
Actually, that's brings me to another idea that I'd like to bring up here, which I was going to, which has got to do sort of with turbos, and it's got to do with the box as well. So maybe I could go through with that here. Whoops, just a second here. That was okay. First, right. So yeah, Zane just mentioned. Let me get my video pinned, spotlighted. Zane just mentioned about this concept of high-speed twin turbos on his engine, and it reminded me that I wanted to mention a little project that I had a few years ago that I put together, and this is actually what I call the world's fastest pencil sharpener. Okay, and it's hooked up to this is a Tesla turbine inside of a CD box. I know it's hard to believe, but a Tesla turbine is just flat discs. It's actually what Tesla said was his greatest invention, and his most favorite was the one he showed on his 50th birthday was his turbine, his disc turbine that he thought would revolutionize the world and change everything. So I was big into Tesla a few years ago and decided to build these Tesla turbines made out of CD discs. And this is a 2 CD disc Tesla turbine, and the CD discs are separated by these 4 magnets in there. And it's all built inside of a CD case. Okay, And here's the inlet for the air pressure. It's got a nozzle that goes inside here, and the whole thing is set up to rotate at high speeds. And the thing about it is it's got no bearings and no seals. It's all just a very, very simple apparatus. In fact, I've improved on Tesla's design by eliminating the bearings and seals and having just the disc float on air. Anyway, the whole thing about this, because it's got 4 magnets, it actually does it go this way? It actually engages. I don't have to be able to show you here. It engages with the 4 magnets that I've got on the drive here for the pencil sharpener. So you can see the handle of the pencil sharpener there is bolted on to this disc, and there's 4 neodymium, heavy-duty neodymium magnets in the disc. And what happens is this drive just sits in there, and when I put air pressure in this, then well, you can see how. Whoops, actually there was another piece that sort of held it in place. But the actual, when it moves on this side, even though there's no direct connection, the magnetic drive makes it move. So when the Tesla turbine discs rotate, it makes the pencil sharpener rotate. And I did a video of it. And the reason I bring that up is this was inside of this container. It was all made to go like this and bolts on to the bottom, bolts onto the wood base here to protect me from this thing running at high speeds, because this is very fragile, making a turbine out of CD discs and plastic and glue and magnets. It's all pretty funky, but it actually worked. I've got a video to prove it, and I didn't want to show that video, but I'll show the excerpt out of it, which is the, oh, I see my live stream is not set up properly somehow. Got messed up here. Let me reset it. Not sure how that happened. Maybe my mouse was roaming by itself. Okay, anyways, the idea is that this case, like I was mentioning, is virtually bulletproof, and that's the point that I wanted to bring up by showing a video that I have here. So let me get that set up and see if we can have a look at it. Okay.
Rick, should I put caustic on the ends of those?
Well, that's the way Lee was doing it with his, for his tests. He would put a little dab or just like a dab of caustic to start it, and then he'd hook it up to his reactor and then note how fast it would nano-coat. And that was with insulation on the wire as well, fine stranded like speaker wire, 14 gauge with the insulation. Okay, so let me just do the screen share here. So this is the Tesla CD turbine pencil sharpener. I don't want to play the whole video, it's like 8 minutes long, but I did want to show the part that there I described the turbine, but I've already talked about that, and I want to show the torture test of the apparatus. I wish I could go full screen with this, but I can't. I don't think so. Okay, sorry, I didn't have the audio set up, so I have to, I'll just redo that part then. Okay, I think it'll work. Let me just redo this. Okay, I think the audio will work. Let me know if it doesn't. So here we go again. It is very strong. You could hammer on it. It won't break. Okay, try a little torture testing of the new polycarbonate box that I've made here. This is for testing turbines, and we have to make sure that it is strong. Feels pretty strong. Let's try it. Yep. By golly, that's pretty god darn strong, I would say. Alright, torture test done. You could shoot it with a shotgun and it won't break. Hopefully. Anyways, that's going to be our protective thing. I just wanted to show that part of the video. If people want to see the whole thing, they can go to my Mr. Fix-It Rick channel, and it's under Tesla CD Turbine Pencil Sharpener. The world's fastest pencil sharpener. And it actually got going pretty good. Maybe I'll show a little bit at toward the end here. It's kind of cool seeing it going. Of the Tesla turbine, 2 disc with the turbine. You need to build up RPM. Let it build up again. 700, 800, 900. We're bogging down, but the 1700, 1800, 19, 2200 RPM. Fantastic. Let's get that pencil sharpened. Oh yeah. Instant pencil sharpening. Yes.
That was pretty cool.
Well, I don't want to play my stepson's music because they'll make me pay for that. But that's a quote from Tesla. I do not think there is any thrill that can go through the human heart like that felt by the inventor as he sees some creation of the brain unfolding to success. And that was so true with that experiment. It was a lot of fun. It was only then that I knew it was going to work. I just sort of winged it all the way, and yeah, it was fun, and it worked. So, but mainly I wanted to bring up how strong that polycarbonate is. That was the main idea there, and basically that's it on that one. Any questions? Everyone's speechless, I know. That's some of the things I did in my past life.
Probably go faster than nano-coated.
Yeah. Well, this is the thing. Yeah, you brought up twin turbo, and I brought up the Tesla turbine and the idea of a turbine that just has discs. Okay,
Yeah,
well,
really.
I did a sort of a thought exercise of what happens when this turbine goes faster and faster and faster, basically. And that can be due to higher pressure, basically, at the inlet, and you get to the point where you have an extreme gradient, because there's basically what happens with the Tesla turbine. This is the inlet here. It's an injection of high-speed fluid going in. It could be air, it could be water. I've run both. And it spins inside in a spiral and spirals into the middle and exits out the middle. And so you get a gradient here of pressure, because the middle here is virtually no pressure, it's just atmospheric pressure. But up here you might have 100 pounds per square inch, or technically you could have 5,000 pounds per square inch or more, depending. And what happens with an extreme gradient with the Tesla turbine is you'll get, especially in the outer edges, especially when this is turning at, Tesla's turbine turned at 35,000 RPM. It was about this size. You wouldn't be able to turn a CD disc that fast. They will go up to 20 to 25,000 RPM, but not with magnets on them, which adds to the equation quite a bit. I've had the CD turbines go up to 18,000 RPM, or even up to 20, but that was pushing it, and it makes such a strange noise, like if it comes apart. Speaking of which, if it comes apart, then it'll be dangerous, big time, especially with flying poisonous neodymium magnets flying through. But anyway, the idea is that you have an extreme gradient in the fluids that are spiraling around in here. Now, I've run, for example, water and air at the same time in a Tesla turbine, just to see if it could be done, and it can be done. What happens is, when it's spinning really fast, the air separates and comes out the middle. The water and vapor tends to stay around the outer edges, because the density is greater of water compared to the water vapor or the air. So what happens is the higher density things tend to go toward the outside of a rotating structure. The same as in a rotating reactors will form a GANs ring, according to the heaviest GANs, and then the next lightest, and then the next lightest will form these rings in the rotation, or similar to centrifuge works and so on. So it's a separation of materials. So what happens in a Tesla turbine, there's such a gradient of pressure between here and here and here and so on, that the different layers going toward the middle. And it is layers. It forms actual layers, multiple layers of sliding molecules of air, for example, or water. And these have such a big shear factor, due to one's going at one speed, the next layer is going at a much slower speed, and the next one's slower, and so on. And that creates a turbulence, or sort of like a micro-bearing turbulence that they are able to slide on. But what happens is, if you have a particle, say this is a particle that's mixed up in there, say a chunk of carbon, some heavy chunk of carbon or something got mixed up. You have these shear layers going on in this layering thing here at the high pressures and high RPMs. And that shear layer will take this particle and start ripping and rotating it, so it basically pulverizes it down to its basic components, okay? And so then you've got, basically, it's like mulched up stuff. And that then becomes lighter and is able to make its way to the center and out. Now, the interesting part is that theoretically you could actually rotate it at such a high speed that disintegration process, that breaking down, ripping apart of molecules down to their basic elemental parts, could act as a decontamination and conversion of materials from one material to another, and so on. Especially when you consider what happens at very, very high speeds on that outer tip edge. You get a plasma. A plasma will form because of the high speed of the particles, forms a electrical charge, and it's a high speed moving electrical charge, makes a magnetic field, and so on. and because it's of the situation it's under, it can form a plasmatic structure there. So I think that the high-speed Tesla turbine, especially with some of the new materials that are coming out recently in different ceramics and extremely high-strength materials, graphite and graphene and so on, in terms of their strength potentials. Some of the flywheels that they make now are extremely high speed. I think you get something like this up around a few 100,000 RPM, and you'll have a totally different situation. You'll be able to convert materials basically from the forces involved. And the funny thing about Tesla turbines is that it puts virtually no wear on the discs or internal parts of the turbine, because the fluid layer tends to create a buffer zone that doesn't allow the materials to actually stick to it so much. So interesting. Anyways, any questions, comments before we move on to something else? Mag drive Tesla turbine. It's a whole other deal though. I'll put that back on the back burner.
Hi, thank you for showing that. I see such a Tesla turbine would be one of the good ways to spin Magrav reactor.
Well, that's
Plasma
right.
reactor.
Yes, that certainly could be done. You can use a fluid drive. You could have a pump, a long distance away that doesn't interfere with the fields of the reactor and so on. Just have fluid lines.
Think about the organs, the church organs, how they worked. They didn't need electricity in the past times.
With the foot pump, you mean?
Yes. So this would be one of the ways how to spin a reactor where you have no electricity.
Technically, you could do it with a foot pump. The Tesla turbine like that one takes a minimum of about 40 psi in order to function, and it doesn't need a lot of air. In fact, I've had one that I had that worked quite precisely with a bearing on it and so on, and I could blow in it and actually get it to start. But to get it to do significant work, like these motors are approximately 90 watts, for example, say 100 watts, somewhere around, what's that, a tenth of a horsepower or something like that. That's a significant amount of work. For a human to do a tenth of a horsepower, you're gonna be pushing pretty hard. It's like, well, it'd be like working out at the gym, basically.
I was thinking about the 2014 November experiments where there were four motors of 5 watts each only. So not such a huge power needed.
Yeah, that's true. For the small reactors, they require less power. But for things like for my 4 reactor setup there, it's I use a sewing machine motor, which is again about the same, 90 watts or something like that, and it does.
That's really powerful.
Yeah, it's quite powerful, but it makes the motor. Well, in the old days, they used to say the difference between a 6-cylinder and the 8-cylinder, trying to sell you the 8-cylinder at the automotive places, was that the 8 leisures were the 6 labors. In other words, this is like the 8-cylinder. This motor will leisure, and you could run it for a long time without it overheating and burning out and so on. Whereas some of those smaller motors, they suffered from burnout problems. I burned out 3 out of the 4 that I had trying to just run one ping pong ball reactor with them. So it depends on your
I
setup.
understand. So we need something designed for heavy duty for 24 hours, 7 days a week work.
Pretty much,
It's
yeah.
impossible
Or
to lower.
overbuild it so that you know, like this one here, I don't have a lot of faith that for longevity on it. I've already had trouble with its wiring assembly here. The little wires were soldered kind of daintily inside, and it actually broke inside, and I had to take it all apart and carefully solder it back together and glue this wiring thing on so it didn't vibrate and so on. And I mean, they're fairly heavy duty. They do have good bearings and so on, but these are designed to run in a model airplane for 10 minutes at a time until the battery runs out, and then you try it again. And you don't generally run them 24/7 for days or weeks at a time. However, the sewing machine motors, they can be run quite a long time. They do have brushes though, and compared to this, which is brushless, which is a nice feature. And because the sewing machine has brushes, some of them actually come with extra brush sets that you can replace them fairly easily oneself, but it is something that wears out and it sparks and interrupts with the field and so on. Yeah, so another idea is a flexible drive, like a Fordham tool or a Dremel tool. You can get or even for a drill, you can get a flexible drive system and have your motor away from the reactor that way.
Yeah, that would be the main point of finding something which is not electrical for spinning to keep away the magnetic fields of the motor from the reactor.
Yeah,
Not
but
use.
you're right with the
By the
test
way,
turbine. Go ahead.
by the way, have you thought about the flows inside the Tesla turbine? How about if you would run it not with air but with liquid?
Well, as I
With
was mentioning,
liquid
I've done
plasma.
that. I've done that with. I've run the same exact turbine. In fact, a Tesla CD turbine that I made out of CDs and so on. I've run it on air and water, and the combination of air and water. In fact, one of my favorite. I should show this, I guess, because you brought it up, and now you made me want to go show it. It's good we bring up some
I
of this
remember
old
one
stuff.
of your videos made long time ago.
Yeah, this here's one that let me just get that out of the way. This is I built a blender, a blender powered by a CD turbine. Let me show you the screen here. I did a lot of strange things in my past life. This is the Tesla CD turbine blender experiment. This is the final test in more ways than one, as I mentioned. So this is actually kind of interesting in an alternate energy way. So maybe I'll let this video play through, and you can have a look at how I managed to make a blender run on a Tesla turbine CD made out of CDs, run on compressed air made from solar power. So it's a solar powered Tesla turbine, basically. And let's just play through here. It's working pretty good. I'm losing air pressure. I'm down to about 50 pounds now. And we're at about 40 in the blender combined pressure, which is not really enough to get it going good. Alright, that's not too bad, not too bad. I'm going to get some more air in the air compressor and give it another go. Okay, we're going to do one lap. So just to let people know, this thing underneath the blender is the Tesla turbine, and it has a pressure hose going into it that has...
Your microphone is still muted.
Oh, thank you, Shandor. I was talking to the live stream, but not to the Zoom. Okay, I just want to say that the bottom part here that we see underneath the blender is the Tesla turbine. It's got, I think it was 28 discs inside or something like that. It's a lot of discs. And it has a pressure hose going into it that's attached to both air pressure, compressed air, and water pressure from the faucet at the same time. So both of these are going into the blender. I've got a foot control that controls the water supply. So this is the scenario. I'm doing a last final run here. I've never done, I haven't like run this thing in and tested it or anything. I just put it together, did the first video, and this is the second video. So I'll have it continuous. Final run here with the blender. I've thrown in a couple of ice cubes just to make things interesting, and we're going to give it a full blast of air pressure with the air tank pumped up to 100 psi, and just the regular pressure from the pump coming in from our recirculating system. Okay, let me double check a couple of things here. Pressurized. And I'll be operating the foot switch underneath here that will activate the air pressure. It's like a little throttle accelerator pedal. Okay, goggles are on. You got ice cubes, everything's in there already, the banana, the apples, the whole works. Okay, turn on the regular pressure first. Okay, here we go. The blender is going around pretty good. You can hear the ice cubes clunking around in there, and that's encouraging. Okay, I'm going to give it a blast of air pressure now. Here we go. Everything holds together. No, it didn't. Whoa, we have a major problem here. Wow. Yeah, well. Oh my God. Woo-wee. Yeah, blew the heck out of my turbine. Bummer. Whoops. Look at this. It still goes around. That's leaking really bad. We got a problem. Oh God. Okay, that's it. Alright, so there we go. Another crazy video by my past life crazy Mr. Fix-It Rick. But it was fun, and I learned a lot through that. I learned that a Tesla turbine can take a lot of abuse if you don't put too much pressure in and blow the CD case to pieces. And it would have actually stood the pressure if I would have gradually put the pressure on instead of just accelerated with that pedal to the metal, so to speak. And it ended up blowing the poor little turbine all over my kitchen table. But I actually patched it back up again with hot glue, got it running again. And yeah, so I've also powered a skill saw blade with the same plastic CD case, and that was a magnetically driven skill saw blade, and that's what actually gave me the reputation as crazy Mr. Fix-It Rick, because that was rather crazy.
The pumpkin experiment?
Oh yes, the pumpkin experiment, where I chopped a pumpkin with a rotating CD turbine powered skill saw on the end of a shaft, basically. I don't know if we have to get into all the past of Rick here. This is more of a plasma group, but I can jam things in once in a while that are sort of plasmatically appropriate. So that's a bit of a broad spectrum in my realm. So almost everything's plasma these days. You can almost look at anything in terms of how can it be looked at plasmatically. How can we look at ordinary things and turn them into a plasma device? Jay has a question. I was thinking about the God game of Mr. Fix-It-Rick in it. I began to wonder if in real life, did Tesla upload some data or instructions about all his secret inventions to like an early version of the cloud or something like that? Maybe he was able to broadcast nights and nights of conversations or even classes to the ionosphere that maybe someday someone might stumble across. That would make a great film. Do you think it's possible? And if it was, do you think it would have been found by now? Well, on the surface that some people say, oh, that's a crazy question. But no, that is actually a very valid question. And the fact is that in the ionosphere now, due to the way the ionosphere works and the bouncing of waves off the inside, well, you can imagine if this was the Earth, and this is the Earth inside, and this is the ionosphere here, let's say. So the Earth's in the center there, and this is the ionosphere around the Earth. Then those waves, there's radio waves that can bounce inside, essentially inside the globe. They hit the ionosphere membrane edges and just keep bouncing. And it's actually a perfect resonating waveform can be set up so that there's rumors that it's possible to tune into like Second World War broadcasts, radio broadcasts, that are still bouncing around inside the ionosphere. So technically, if Tesla knew about that, and he knew a lot about the ionosphere, he's the first one to measure the harmonics or the frequency, the harmonic frequency of the ionosphere, as well as the Earth itself. He measured both of them. The Earth, I think it was around 7 hertz, and the ionosphere at the Earth was more like 6 or 4 hertz, I think, and the ionosphere is 7.83. It's entirely possible, if Tesla was even smarter than we think he was, that he could have imprinted his. He could broadcast around the world with his gear. He had, huge towers and spark coils and extremely high tension Tesla coils and whatnot, designed for broadcasting and for listening. And he could very well have encoded things and put them to the cloud, literally, through the clouds into the ionosphere. And maybe they're available still to listen to for those who have the ears to listen that can figure that out. Interesting point, Jay. Thank you. Alrighty, who else has something to show and tell here? I've been yakking away for too long. Probably put a few people to sleep by now. So we need some live action, reactor action here to get things going. I could fire up my one in the background, but the belt's a little stretched and it's having a difficult time today. What about you, Lee? Do you have anything new this week?
Not much new. I've been making some more car Magravs and testing them, but
Making more Magravs. How many do you have now, Lee?
Gee, I don't know. I'd have
And-
to look at my spreadsheet.
And how many is enough? How many reactors does Lee think is enough? Just one more.
No, I'm up to 38, and I'm working on a couple more at the table here.
38. You were at 20 something last week. Holy cow, that's great.
But again, I got 25, 26, and 27. They aren't working at all, whereas they're almost the same as another one that was working. So I'm getting inconsistent results. And then
And by working, just to let people know that you mean it nano-coats your insulated wire in a
that's
fast
right.
manner.
I got 9 days and counting, and it hasn't even started the nano-coat yet on those three.
Really?
Whereas
And
other ones are
it's all the-
nano-coating in
All the same
3 or
condition,
4 days.
same procedure, I guess, and so same caustic and
Similar. I'm trying to zero in on the best way to go, kind of thing, and but I keep getting these funny results that well, they're just plain funny.
not consistent. You mean, or how funny
Yeah.
is funny?
Well, they're not nano-coating the wire like I think it should.
Right. Mm-hmm.
So, I mean, I keep changing things, but I'm not changing anything big. I'm just changing little things now.
And
So,
this is all the latest ones are the car Magrav units. Like they don't have an actual load on them as such.
And by load, what do you mean?
Well, you don't have current flowing through the wires like you might on if you're plugged in. Did you actually have your Magrav when you were doing the test with a Magrav unit, a home Magrav unit? Did you actually have it plugged into things when you were testing the wire?
No, they're all no power to anything.
Oh, okay, I see. I
So,
thought that might have started the nano-coating faster or something like that.
So this week I've been putting them into cars. I got one in the Dodge truck here. Of course, I got one on my truck, but I'm not driving my truck very much. I just put one in another little car this morning, and someone's put one in a I don't know where I went to here, in a neighbor's Jeep, and someone's coming by tomorrow with this Chevy truck. We're gonna stick one in that.
Oh, that's great.
We'll see whether we actually can improve on the mileage, the real test.
Yes, right. Or other results, if it makes somebody feel like every day's a Sunday drive and they feel great. And, some people say that the ride changes and the sounds of the motor and so on. So,
these three here, I was putting the epoxy in the middle. I glue the two coils in epoxy on each cap, and then glue the two caps together, and there's about a 1/2-inch gap in the middle.
Mm-hmm.
And they didn't work. But then on this fourth one down here, same thing, epoxy in the middle, and I get 2.4 feet a day of wire being nano-coated. So, that's what I mean by inconsistent.
Well, it's slightly different than the other ones. You have a quarter GANs. What does that mean? Quarter filled?
No, it's a 1/4 teaspoon of GANs in the 5 ounces of epoxy. So this one had less GANs than these other ones, but further up, some of the good ones had, like this one, 1/2 feet per day had 2 teaspoons of GANs in it.
Mm-hmm.
And that one had 2 teaspoons. That one wasn't bad. 1 teaspoon, 1/2 teaspoon. And then I was sort of starting at 1 teaspoon, or I guess 2 teaspoons, and I was going right down to a 1/16 of a teaspoon for these tests here that aren't starting to show results yet because they were just done yesterday.
Let's see.
So I'm trying to find the lower limit of how much GANs to put inside the epoxy here with these tests by going down from 2 teaspoons right down to a 1/16 of a teaspoon here in one of them.
Mm-hmm.
But
and you're using brass GANs? Is that what I see there?
Yeah, I had I got a bunch of brass GANs here, so I've been using it. Now, brass GANs is mostly zinc, okay? What I found, I had these brass plates, and I ran them through about 6 times through my process over the last year. And the funny thing is, all the zinc got sucked out of the brass plates, and it was like a real punky copper that was left.
Oh.
And then it would start making copper GANs.
Oh, right. Interesting.
So I'm thinking, the brass GANs is it's sort of whitish with the bluish tinge from the copper, but the whitish part is almost all zinc, is what I'm guessing, because brass is 60% zinc. But
yeah, good point. You basically leached it out
of the middle of the plate, atom by atom.
Yep. Yeah, it's sacrificial. That's why they use it, like on ships, as they bolt it onto the back by the motor, so the aluminum doesn't corrode in the motor as much on the boat, and it'll tend to corrode the zinc instead as a sacrificial anode. Interesting.
Yeah.
So that might be an interesting way, actually, to create a special kind of nano-coating on the copper that's left out of your brass. Because you think of it, if the brass is porous, starts to get porous from the zinc being leached out, you basically have a bunch of holes in there to start with. And then if you nano-coat that copper, instead of just getting the copper GANs out of it, which will tend to melt everything back together again, but actually do a nano-coating process while it's still porous, and it should create even more of a fractal sort of multifaceted nano-coating, I would think.
I got a question for you guys. I was thinking in addition to the GANs I put in the epoxy, I was thinking of putting a bit of sugar in there. I bought some icing sugar today. I was going to put a 1/4 teaspoon icing sugar in there along with my GANs. Any comments on that?
No, this is right in with the GANs. It's not epoxied or anything. You're talking about just in the
I'm thinking of putting it in with the epoxy.
Oh, with the epoxy. Okay.
Yeah.
In with the titanium oxide GANs.
Think it'll help? Any guesses?
So you bought icing sugar, you said, or regular sugar?
No, I got some icing sugar because it's ground up nice and fine.
It sure is. Well, it's. I'll let you know. I used to work in a sugar refinery, in the lab of a sugar refinery, and we would go to different parts of the refinery and take samples and so on. So one of the parts was the icing sugar area. They have the icing sugar area all sectioned off with a special explosion-proof room because icing sugar is explosive when it's in a fine powder dispersed in the air. It just takes a flame and boof, the whole thing goes up. So think of it in terms of in the epoxy, evenly dispersed through the epoxy. You essentially have the potential between these particles, but yet they can't explode, they can't catch on fire, they can't do anything, but yet they still have that gradient, that potential between them if they're evenly dispersed. And then working with the titanium oxide, which is what is it famous for? Well, lots of things. It's a solar, you can make it into a solar panel, for example. What else do they use it for? It's almost a perfect reflector. It could reflect onto the other particles or something like that. Who knows what could go on inside the epoxy once it would depend a lot on how the conditions were as the epoxy was setting too. Like, are these particles all going to be evenly dispersed, or are they going to coagulate in clumps together? Maybe there's a certain rate of, do we want the epoxy to freeze right away, or do we want these particles to sort of align with each other first in a some kind of way that might take 10 hours of slow dry epoxy or whatever. These
Yeah,
are
this-
the important questions that need to be answered. I'm sure
Sort
you're
of
up
got
to it,
this
Lee.
idea from the Alexz speeds there from last August, or a year ago last August. He had brass GANs and a bit of sugar and I forget what else in there.
Yeah, Mr. Keshe has mentioned quite often sugar or the CH3, depending on. He sometimes uses the terms interchangeably, actually. So he'll mention CH3 as sugar, or sugar as CH3. So
Anyway, next 4, I'm just wiring them up now, just gluing them together so I can stick them in the pots and put epoxy in them. So then those next 4, I'm going to put a bit of sugar in them, see what happens.
I was thinking too, what the chemistry of sugar is, what C12H22O11, I think. If my university mind kicks in properly. It was a long time ago, but I think that's so it's carbon, hydrogen, and oxygen basically. So you're adding the carbon, the hydrogen, and oxygen into that environment. Seems like a good thing.
Hey Lee, whenever you whenever you're testing your car units to see about the nano coating, putting a wire in between the two.
Yep.
A copper wire. You don't put caustic on either end, do you? You just attach the wire? Because that's what I did, man, and it's already looking like it's doing its job.
Yeah, well, I got this jar. It's caustic and brown sugar. That's what I paint on all my bare copper joints.
Yeah.
So inside the unit where I join it to the nano-coated wire from the coil, it gets some caustic and sugar solution, and the outside connections where I tested, I put the same caustic and sugar solution on there just to hopefully make it flow faster, get going faster.
Oh, you do both ends then.
Let me ask you a question real quick. Okay, look, this is my these are the wires that I'm gonna use. They're in this cable right here. I got both ends inside the nano-coating bucket.
Mm-hmm.
But how would you attach those to those wires? So where there would be a good connection in where they won't break off or anything.
I don't have one that's opened up. One that I'm testing, I had the 2-foot lead coming out on it, and then I put the old Western Union splice on it.
I got you.
Okay, so this is just like this is just a test Magrav. It had a 2-foot lead on, and then what I was doing was then I put a 12-foot wire in between the 2 1-foot leads basically, or the 2 feet, and I'm seeing how long that 12-foot wire, and then I was going to put different things in between there, or different lengths of wire, just to see how it came out.
Do you have GANs balls in the center of those?
Yes, I do. There's one that I whoops, that's too bright. There's I don't know if you can see the GANs ball in there.
Yeah, I see it. I made one that completely sealed off the 2 different coils.
There's my pot of GANs balls.
Yeah, I got you.
So
cool, man.
And I'm still putting the flat coil in the middle there. I haven't tested it yet with the wire sticking in the GANs ball. So
thanks.
Right, that was the advice last time, was the wire in the GANs ball technique. Eh?
Yeah,
Was it?
the
Was that from Mr. Keshe, or who gave that advice again?
that was John, I think.
Okay.
Yeah, I put a coil inside the center ball that's inside the spear that's in the center of that car unit.
Yeah, the other thing that John brought up was that using the vinegar to wash your wires, actually wash them in soap first and then the vinegar. And boy, did that ever clean up the wires good. I really recommend that now. So that's before you put them in the nano-coating.
I have a question about the wiring. I was watching Mr. Keshe, an older workshop yesterday, and he brought up something that I had forgotten about. And I was just wondering if you guys think about this when you're connecting your wires. Mr. Keshe said you have to keep track of the way you cut the wires off of the spool or whatever so that you don't turn the wire around, you know, the way it's extruded. Do you keep track of that when you're connecting one wire to the next wire, that you keep them going in the same direction from the same spool, so to speak? You know what I mean?
Of course, yeah, I know what you mean. I know he said that. It's difficult to. He used to say that you'd measure the voltage on the full length of the wire, and you have a positive end and a negative end, and then you kept the positive negatives in line with the flow of the plasma or something all throughout your system.
Yeah, that
And
could
so
be.
you know what?
Maybe that's why you have inconsistent results. If you have even just one wire turned around, then you're blocking the flow.
Well, when I make my coils, they're all coming off the spool the same way. Well, normally I got a 45 meter length. What I do is I buy number 8 7-strand wire and then strip it and uncoil it with mostly with the drill, and then there are a little bit left by hand. So I got 7 strands of 16 gauge wire that I'm using, and those, I suppose, the different length, the different lengths could be different on where I spool them, but basically I can get 2 sets of car Magravs out of the 145 meter length. And when I wind the coils, I sort of mark which end is the the end coming off the spool, and then when I put the coils together, I always stick them together the same way. But the thing is, I'm not really sure I'm putting them together the right way, thinking plasmatically, because it goes through the gravitational one way and it goes back out the magnetical the other way, and which way should it be? So I'm sort of putting them together all the same in a sense, but I'm probably doing it all wrong if you think of it plasmatically.
How about the test wires that you use, the 12-foot test wire you were mentioning, right?
Yep.
Is that always taken off the spool in the same direction, let's say?
No.
That might make a difference in the testing, because maybe those 3 in a row that won't nano-coat, maybe they were sort of backwards from the way you were taking them before, or something like that. It's a good point that was brought up by Mario, because it does make sense in a way, especially with that kind of wire that's fine strand wire and so on. It'll be stretched and pulled in a certain direction when it's made as a wire, and have almost an orientation to it. It may tend to draw the vapors one way. It might act as sort of a diode to plasma in a way. It only flows one way.
Let's look at that a bit closer. Okay, I got a spool of 1,000 feet of red and black wire here. What do? You measure the voltage on the wire to see which end is positive, which end's negative, and then the magnetical's positive coming out, so you connect it to the negative end to the magnetical, and and the positive end of the gravitational. How do you actually orientate the wire properly?
Well, the idea, I think the main idea is that if you start out with one coil with your coil is made out of a piece of wire, you just continue with that piece of wire, make the next coil, and each one made the same way. You wouldn't cut off a piece of wire and turn it around and make a coil. You would just make it off that continuous wire so that each coil is consistent with the field, so at least is all the same. I don't know if we can.
You gotta keep track of what your grab out is to your magnetic in, and throughout the way you wire it through the coil, toward how you orientate it.
Yeah, I think that's the way they teach it.
And so you almost have to mark each end of your coil as plus and minus, or you'd have to mark your coil plus and minus, and then as you're assembling your coil, you got to think plasmatically, which always have it going, I don't know, plus to minus or something, or minus to plus. I'm not sure which way. I guess it would be minus to plus or something if you start with the gravitational one.
Well, you're using the same wire for the whole coil, so that shouldn't be a problem. The biggest problem is making sure that you use, when you connect, your connecting wires, I would think. Actually, I never really considered it until now. I might have had problems with all my connections. When you connect the coils, you're using single strands. You got to make sure those are going the same direction of as the coils. As long as everything's going in the same direction, I don't think it really matters, right? Like what Rick said. But the connecting wires, because you just have these little pieces of wire there, so you got to really keep track of which way they were cut.
Yeah, it would be an interesting experiment, Lee, if you could make like several connections with the wire that came off the spool one way, and several connections with the wire going the opposite direction, and see if it makes a difference in the nano-coating. It's the same wire, same conditions, but one's trying to go one way and one the other way. Maybe there's a
okay.
I'm
trying to sort it out in my mind what the right way is. Is it supposed to be
as long as it's consistent? And that might be a problem with your Magrav units in general. Some of them are working better than others, and you don't know why. It might just be you have one wire that's turned around. That's all it would take.
It could be that, or it could be the test wire itself could be turned around too. That 12-foot wire. Maybe if it was, the other way around, it might nano-coat easier.
Yeah. Well, like on all the units I'm doing now, I'm putting the 6-foot lead that I'm going to use in the car. So yeah, those 6-foot leads that go from the Magrav to the battery, they should, I guess, have an orientation to them the same as the Magrav coil wire. So the question is to get the flow going all the same direction through all the coils with respect to what the positive negative end of the wires are.
Right. Yeah, it's a tricky thing.
I've sort of ignored it because I think Mr. Keshe said it would make about a 5% difference or something if you had them all lined up right.
Yeah, thanks for that information, man.
But it's not that easy to do. It would take some effort.
Mm-hmm. I see Paul has a comment here. Can I get the PDF of the reactor building, please? Paul, can you explain what do you mean by the reactor building, a PDF? Is anybody... I don't know what he means by that. Can anybody tell me?
I haven't seen a PDF of it.
There's a PDF that's Ali has started about building tips on building reactors. I put a few comments in the group, his spaceship group, and he started a PDF and started to put it on Facebook. But is that what you mean, Paul?
Is he talking about the car reactor or the other reactors?
Right, I'm not sure. PDF of the reactor building, please. Paul, do you want to explain or write in the chat a little better what you mean? That would be good. Alright, let's continue on here. What else? You got anything else, cool things there, Lee, that you're hiding on us behind you there? Come on, show us your secret projects.
Well, that's just my hiding in behind me. There's just all my GAN spots, and I'm not very good at GANs, so
yeah.
I could show you my copper GANs. It's all black, and actually the CO2 one went not bad this time, but
yeah.
and there's a bunch of CH3 ones in long, tall, glass bottles that are actually they need to be reworked.
Yeah. Okay. Thank you for showing your stuff. They just announced Trump as the next president. Believe it or not, news brought to you here from the Keshe Plasma Reactor Group. Donald Trump. It's hard to believe, but apparently that's what it was looking like earlier tonight. They just announced he is the next president of the most powerful country of the world, supposedly. And yeah, okay. Well, you know, it might actually end up being better. I just thought it might be a sad day if Hillary got in, and it might be you know, lots of more wars, so maybe it takes a crazy man for crazy times, and maybe it'll all work out even in the end. Hard to believe.
Well, now that he's president, he'll have somebody else writing his speeches. They'll tell him what to say, so maybe he'll sound not quite as ridiculous as he did before, but it'll be more evil under the other side of it, you know, because he'll have his handlers telling him what to do. Now that he's president, he's no longer the boss anymore.
Yeah, well, he won't like that though, and he'll find a way to fight back, or it'll squirt out somewhere in his situation, I think so.
Yeah, I guess it didn't help George W. Bush, did it? He had a few ridiculous things to say as president, but
yeah, and people liked his dumbing down of stuff actually, and his, you know, sort of casual, funky way of stuff and so on. So I'm sure they'll like that with Trump as well.
Well, meanwhile, back to reality, if we can. I have
back to the real world.
Yeah, back to the real world. I have something, if I could show you.
Absolutely.
And I just had an idea, but I'm going to put my camera. Okay. I don't know if you can see it.
Looks, yeah, there we go.
Okay, I'm still seeing you, but okay, you can see it.
I'm going to spotlight it. There we go.
Ah, there you go. Okay. This is my version of a GANs guitar pickup. Right? I took actually a pencil lead. Thought this graphite, it should be neutral and conduct the flow, and I wrapped it with tissue with CO2 water, and then I wrapped a coil around it, and then I put it's got a plastic straw basically around it, and then I wrapped another coil around it for the magnetic and gravitational. Now, I kind of have a question, and it just occurred to me something. So I don't know, maybe I've already answered my own question, but what I did was I turned the ends back around here like a paint pen. And I'm going to connect this to a guitar jack. right? Oh, here. So I have this guitar jack, and what I was thinking is, this is a shielded, mono-shielded cable. It's got 3 wires. So the inside wire is going to get connected to the magnetical, I'm assuming, and then the second wire around that will go to the gravitational, because that should be the ground. And then you have this third wire that's wrapped around there. That's just the shielding, right? So I got it looped around, something like that. And I think I'm just going to connect the wires to that and plug this in. What do you think, Rick? With that connection?
I would absolutely do it and give it a try. Why not? Yeah.
Yeah.
You should be able to get some sort of action. You've got these individual coils there, and they're all joined together at one end, these coils?
No.
Okay,
no.
they're just
But now that's
bent over.
Yeah, that's the thing. Is again now this is a mono cable, but now it just occurred to me that maybe what I should do is connect the hot here to the gravitational out, and put the negative to the gravitational the other end here, and not loop it back on itself like I've done here, and have a mono cable for the gravitational coil, and then get another one of these cables and connect it to the magnetical, and go stereo. See if I can't get a different signal for the magnetical and the gravitational. I'll have to.
Yep. Yeah, definitely. If you keep those coils separate, so you don't want them grounding out against your ground there, because that'll just be like holding your finger on the hot lead of the thing. It just makes a buzz. So
they're wrapped in plastic straws.
Yeah,
they slid open a straw, snapped it over the coil, and then
what's your intention? What would you do with this? Do you hook it up to your guitar?
No, I'm thinking about plugging into my mixing board, and then bringing it near my reactors and seeing if I can't, record maybe the sound of the reactors, or at least just listen to them through the mixer. I'm assuming that program, like I could use GarageBand, or I have Logic Pro X or whatever. I mean, this is my actually recording computer. So I'm see if I can't record the Magrav fields, even just from.
Yeah, try a motor or something first. Something that's a loud field, or maybe some light bulbs are quite loud. They'll just sort of hum, and you should be able to get some sort of effect from different lights or motors or things like that have a feel that you know of, and then make it sensitive for the finer fields of a rotating reactor, which is a harder thing to get a handle on than just a rotating motor.
Yeah, well, I have my little pyramid reactor spinning, and it's got a motor right next to it, so I'll try that on and off. And it also means this is the only broken cable I have. So I either cut up a perfectly good cable. I might have to go buy a cheaper one, the cheapest one I can get, and I need another jack. But okay. So I think I'm going to try that. And also, what I was thinking is
so the other way to go is, instead of putting breaking your cable, is to just get a jack, like a mono jack, or a stereo jack, and use a stereo cable as well. And then you put the jack on your sensor end, and then just plug your cable into it.
How do you mean? You mean just attach this to one end?
You would get a female jack and put it on your sensor, and like wire it into your sensor, and then just plug in what you have in your hand into the female jack. Plug the male end in. You can get it at an electronics store or a place like that.
That's a good idea. Right, that's what you're doing. Yeah, that's right. Okay, great.
Yeah, I can show.
Yeah, okay, I'll stop I have something else to show you too in a minute, but let me go ahead and.
So yeah, like this is an example of one of my test tube sensors, and it's got the 1/8 inch phono jack at the end here, so I can just plug a regular
Right.
phono plug like that into it, and bingo, you got a
Right.
sensor on a wire.
Right.
Yeah,
That's a
that's
great
cool.
idea. Okay.
That's cool, Mario. I think I was just looking at. I was just thinking about GarageBand today. Actually, I've used that in the past and so on. That might be a good way to hook up the same basic sort of system as the Audio Hijack Pro, because you can do live sound effects and different. You can definitely alter the gain and so on through different modules in GarageBand. So it could be quite
It might be
useful.
interesting to record it and then also play it back into the microphone or play it back to the reactor or whatever, you know.
Yeah.
I also the fields from the CO2, they should be many octaves higher than the human hearing, maybe. So I was wondering if I record something and then I use the program to bring it down an octave.
Well,
Record it, bring it down an octave.
you could record it. What I do is I do that basically live in real time. I use a pitch control. In fact, I use 3 of them in a row so I can really alter the pitch. And so if I hear a lot of high-end stuff, like sounds like sometimes Morse code or just birds twittering or something, and a lot of really high sounds, I lower the whole pitch, from down to instead of it's got it takes it down into the bass zone, and that way our ears can hear it more easily. Otherwise it's up in doggy zone, or women who have fine hearing. Most men can't hear the high tones as well as women do. So that's one thing to think about there. You can do it in real time, and that way you get more of a gist of the immediacy of whether there's something coming through or not. If you do it later, it's okay, but it's kind of after the fact, and then you're just tweaking it. Whereas in real time, you get immediate feedback, so you can alter it a little bit. And sometimes a little bit makes a big difference in that alteration of the pitch.
Does the GarageBand have that in real time? I don't even know. I never tried.
I think that it does. I think you can install different modules, and there's pitch control module on I think I forget now if it's VST or one of the. Or actually, I think it's Apple. It's called the AU pitch, all one word, AU pitch control.
I have that on Logic. I have pretty much everything from on Logic program. So, okay, that's cool. I was also okay. I also did this. I'll show you this.
And by the way, you can also go the other way. If you have a bass tone, you can also raise up the octave and make it into something you can hear.
Yeah, well, also I was thinking about those. When they found out the elephant, somebody recorded the elephant. They just recorded nothing in front of a herd of elephants with a really high sensitive microphone, and then they brought up the sound a couple of octaves, and they found the elephants were talking to each other extensively,
Right. So it's like they do that with whales, the other way around with whales. With their high-pitched sounds, they'll transfer it back down, and if they have low-pitched sounds, that they can transfer back up. Go ahead.
Okay, let me show you this. I don't know if you can see this very well.
Yeah, it looks
I got
cool.
2 of these. Yeah, well, I'm trying to make the the Lakovsky oscillator.
Mm-hmm.
So I have 2 of them. I just took, instead of a tube with 2 balls on the end of it, I just took a wire and looped the fields back.
Oh, right. Yeah, great idea.
Mm-hmm.
Mm-hmm.
So now, I'm thinking.
Now, here's a clue to this. According to the Lakovsky thing, there's a definite relationship to each of these coils, right? Did you take that into account, being a musician and so on? I imagine
I
you did.
traced it off of the Flower of Life, but like everything I made myself, it's not really very accurate, so it's probably out of tune. But yeah, those are the ratios of the harmonic overtones. So
Okay, well here's a way that I thought that you might be able to make it more exact, which is a very simple method, is similar to what Tesla used. Instead of counting the coils and so on of his Tesla coil, he would weigh the wire. So if you weigh the wire, you'll get the proportions. They'll be in direct proportional results. In other words, if it's a phi relationship, 1.618 or whatever it is for phi relation, then each one will be 1.6 of the next one, and you can measure it by the actual grams weight with a sensitive scale and cut the wire to the right size for that octave that you're working with to get the next note exactly.
Yeah, that's interesting. And I'm wondering, like, the Lakovsky, the oscillator is connected with silk string. I've got them glued to straws. Is that going to restrict? I mean, it will restrict the oscillation, but in a plasma environment, the field should be going back and forth, back and forth, back and forth that way, right? Or any suggestions on that or comments?
Well, that's a good point. Silk thread has been used for many centuries, actually, as a means of suspending charged objects. They did lots of experiments with charging things originally with electricity and so on before they had batteries and that. They would use static electricity in many ways. And it was always the silk string was important to isolate the apparatus and to be able to charge it in the air without it grounding out to the ground and so on. So that's very interesting. Maybe we should be using silk string to restrain our Magrav coils, because it is possible that they lose their potency by being drained off into certain glues or whatever. On the other hand, some glues might add to the coils and make them more potent because of the offering of the hydrogen available from the plastics. So the jury's still out on that a bit.
You think silk is nanomaterial? I mean, it's from a spider, right?
It's from silkworm, actually, I think. Yeah.
Silkworm, right? Not a spider, but yeah. But I mean, it's organic. You think its properties are nano?
Well, it's definitely got some very magical properties, as does the stuff from spiders as well. I have a video of a leaf that is suspended at windshield level in the middle of the road, this little country road that I was driving on from this private road in this person's property, dirt road. Driving along, suddenly there's a leaf suspended, almost like that in movies sometimes they'll suspend stuff that's floating around and you'll move but everything's still suspended. So I came up against this leaf and I stopped, like, what's this leaf doing? And there's trees, but they're about maybe 30 feet up or 10 meters high where the nearest limb is and so on. I'm just astounded. What's this leaf doing in front of me? Right in the middle of the road, right at windshield level. So I get out and I look, and sure enough, there's and we're talking about not a small leaf. This is a huge, like 8-inch, 9-inch maple leaf. And it's got a spider web, a single spider web going way up to this branch up in the tree, and it's sitting there just dangling. And I was amazed, so I actually backed up and went around it a bit and just left it. I came back the next day and it was still there. I could not believe it. This was like, maybe 12 or 16 hours later. I came back later on in that day and it was gone. But I was amazed that that spider web could be that strong. And it was like not blowing in, it wasn't a hard wind, but it was blowing back and forth in the wind, moving around and so on. All suspended. I should show the video if I could find it, but I don't think I can too easily here. Sorry, that's another video. Okay, so what else about that? Spider webs and nano-coating silk rather. It could be. In any case, it's a very good insulator, so it doesn't conduct static electricity. Maybe we should make our reactors out of silk reactor. Could work.
Can you nano-coat silk? I suppose you can nano-coat anything.
Maybe it's already nano-coated.
Yeah.
Mark.
Well, I've got
go
my reactor spinning, and I've got those 2 oscillators on either side of them, and I can feel it. So there's definitely something, even if it's just shielding the reactor or something with the nano-coated copper, but I can definitely feel those. And it's actually quite nice. So there's definitely something going on when I get the pickup hooked up. Maybe I'll get some more information, so I'll let you know.
Yeah,
Thanks.
Interesting. I'm glad you're experimenting with that. I think if you can get it working, you're going to love playing around with it, being a musician and so on. Sometimes you get musical tones coming through with various reactors, and especially if you start working with the high voltages and so on. So yeah, and you can also put a diode in the circuit if you want to make it a little have more for electromagnetic spectrum stuff and so on too.
Yeah, I'll try different pickups with different GANs too.
Yeah.
See the difference in that way. So, all right, thanks, man.
Very good, thank you. Okay, Mark, we got to have a look at what you're doing here. It all looks very interesting, so you have to explain yourself.
Hi, Rick.
Hi, how you doing?
Good. How, buddy? Hi, everybody. From Mark from Detroit. Just to introduce myself.
Very good, thank you.
I haven't been on in a couple of weeks, because it's been so busy, and I've been busy, and sometimes you get to the point where you have to think about things, and I'm all by myself, right? So you have to, you're a creator, you're an engineer, you got to go out and buy this stuff, you got to go out and think about it, you sit down and think, think.
That's true. It's buy, think, and
because
heavy on
you're
the
all
buy.
by yourself,
Yeah,
right?
Same with me. Yeah.
So it's just funny how the creation started a year ago, and now we're just a year into it, and you've been into it a long time. I mean, you stumbled on Mr. Keshe 3 years ago, and we bumbled on it about a year ago. And like I said, I'm just a guy in a dungeon in Detroit, in the basement of my mom's house, who's 90 years old, and I got my backstory is just like, if you wanted to hear about it, it's not that fun, but here we are today, and now we got all kinds of good stuff, and we have hope. I think there's more hope than anything.
That's right. In spite of whoever gets elected in as president, in a way it doesn't matter as much, because now people like yourself have personal hope. Like you've basically struck you've claimed your spot in a way. You've made a stand, and in many ways you've made lots of stands, but you've taken a stand in the sense that you've decided that this work is worthwhile, and that the substances you produce are worthy of collecting, and they're important, and all of this could have an important implications in whatever world does come. So, it's a
And you
big
know
deal.
what? I said to myself, even if it doesn't, it gave me inspiration for hope. And
Exactly.
by doing it, I have desire. And with the desire, it gives me inspiration. And with that inspiration, it gives me that energy to continue on.
That's
That
right.
energy.
Yeah, for certain people, I mean, as one goes along in life or on a spiritual path, or life is a spiritual path, we overcome obstacles and go through life and so on. And at a certain point, you get sort of burned out on all the usual tricks and distractions of ordinary life, and one can get sort of reclusive or avoid contact with society and life in general and so on, because you just don't have the urge to do all the ordinary stuff of humans. You've been there, done that. That kind of phrase kicks in, and sometimes it's necessary to just go inside and look inside and follow your own soliloquy and aloneness in a way, and find oneself there and use that energy space and work with it. And I think that's important, and it's just part of the process that eventually.
Well, it's a process that we were on a path. Or put it this way: 5 years ago, 3 years ago, 6 months ago, these things just weren't possible. And like Keshe says, like he made, or prophets or other, uh, information that has come to our minds at other times have never been this way before. When you put the charts together, the pluses and the minuses, the all the things have to align. It's the stars, it's our heavens, it's our universe. If all these things didn't equal to this point in time, we wouldn't be here. We would be in the 1945s, or we'd be in the 1900s, or we'd be in wherever point in time there we would be. We're spirits we have never left this planet. We are a people that keep on rotating through this planet. And I think we're to a point now, the rotation becomes a reality. The reality is what we're seeing in front of us. The rotation is what we've seen behind us. The motion is what we are looking for in front of us, and what we are allowing us as humans to allow ourselves to believe there's something more than ourselves. This is the beauty of it right now, that we could never, people that couldn't. It's like sending the message on Paul Revere on the horse. Tonight we would send the guy out on the horse. Da 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 da. That such and such is the message goes out as such and such. Whereas the message came out real fast tonight. Messages come out faster and faster. So now we are allowing ourselves to communicate faster and faster, which allows information to come in quicker and quicker. The quickening, the faster it comes in, then the ability to process the information seems to be quickening from the children to the adults. Like I said, I have a 90-year-old mom who keeps going through things that she keeps telling me this would never happen 20, 30, 40 years ago. And I'm trying to say to myself, well, why make sense of it? But she's making reality for myself to understand that as humans, we are allowing the process to happen. you cannot stop humans from processing what is about to happen or what is happening. We are allowing ourselves to imagine that these things can actually work and affect us. That's what Mr. Keshe wants us to think, that if we take these few elements that he's given us to affect the parameters in which we live in, if we could just affect these parameters just slightly for health and energy and thinking, just slightly, it alters everything. Just like the election, just like the everything. If it's just tweaked just a hair, just if we just alter something just a little bit, and that's what we're trying to do, is just get an alteration from our time in which we're in right now. I think that's what we're trying to achieve here. It's just a little bit of altering of what our reality is. And if these things that we see in front of us that we work on each and every day, in our free time, we still have to work, we still have to make a living, we have to pay our bills, but if we can alter just a fragment of what we're doing, that might change our outcome. And I think that's what we're seeing, is change in the outcome, because we're allowing ourselves, we're waking up to the beauty of these. I think these are just like play toys for the universe to tell us, children, wake up. Here we are. You can get the energy from this. You can get these things without too much manipulation, without harming our universe. And that's why we're being introduced to it, because we're at that point in time that we can relate this point to each other through a mass media. Once we say these things are put out in the universe that come back to us, just like what we're trying to do. That's why we're trying to make all these things that go in and out. And it's funny how I made these things. I started from a really humongous apparatus of coils and height, and then I said, oh, that's too big. And I said, oh, let's go. And then we went down to a smaller version, and then I thought, well, let's make a medium version. As a creator, we're trying to find the happy medium. And this is I never attempted to think about any of this stuff. This is just my creation in my mind, and I didn't, in a free flow, in a grand gesture, this is where I went first, is this humongous thing that I'm still working on. It'll work, all these things will work, but then I went from big to really super small to sort of medium, and this is where I'm working right now. So like I said, Rick, we're going I'm just one guy, and I'm getting a lot of information in my head at one time, and then we have to decipher it and work on it and go out and buy the parts and decipher it and work on it. And that's where we're at right now, is deciphering and working on it. And for one person, I'm working diligently to try to make some things happen. So, and I say to myself, now that I have all these pushing energies, I say to Mary, the consulate, our counselor for the United States, I push to her. I says, Mary, please, just make all the energies bring up positive feeling for everybody, and stop this negative hatred towards one another. We have to lift up the happiness towards one another, and look what happens. We're in a happier state right now. I feel like we're in, like the energy is really, tonight, or just like waking up this morning, I woke up crying because of personal things, but today, now, I feel lifted up. I feel energized up, because and sometimes these things You don't really want to work on them when you're in a low state. And there's been, like I said, for like 3 weeks, I didn't touch anything. And then in the last couple of days, boom, lots of stuff had to happen because energy was coming our way, coming my way, coming my way. And now I really feel energized to work more on things that could possibly happen.
Yes,
And
I
I could
feel the
go
same way that way. Mm-hmm.
a lot of detail here. There's a lot of detail I could get in, but I just wanted to say that today is a good, positive energy day. And I'm very, like I said, I started out on a low and I'm ending up on a high. And this is just a representation of my work that, we diligently try to get to a point that we want to say to people, hey, there's another way of doing things. And this is just another way of saying, hey, there's a
Can we get a closer look at that, Mark?
What's that?
Can we get a closer look at that?
I
Which
like your.
one? Where do you want to start? You know what I'm saying?
Well, I like
the
new medium one.
You know what? I just want to say hi to everybody, and this is a good day.
Right on. Well, I really like your medium-sized one that you were pointing out there. I think it's the newest ones, the little ones on the right there. Not the little ones, but the white medium one there. Yeah, they're really cool looking, and they seem they have the right proportions somehow. They look pleasing geometrically.
Rick, it's funny you should say that because I had these on this unit, this big stacker unit here, and I thought, because these were a 5, and I thought 5, and how do I, and the wiring in 144 taught me so much more on this unit here, these units. Let me turn my, because I'm looking at you. I can't, I'm on little screen. You don't have a spotlight. So in 144.
Just a second here. Sorry, I should have had that spotlighted. There we go.
144 taught me something about these units that I've been building. Because I had see, this is just I had these all on a large frame, because I'm working on, this is my major frame here, and I'm starting to nano coat this one, which would be this one, but I'm starting this one. But then I started working on these, like I said, Rick, because I jumped from this big one here to these little ones, the little mini ones that we talked about a couple of weeks ago. And I'm still working on them. I still have the exact thing that I needed to do. But then all of a sudden my thought process stopped completely from here. And I know exactly what I need to do with these, but my thought needed me to jump to this, because I thought, well, I needed to get these, and I wanted to put them on a frame like that, but then it was too big. But then I said, well, break them down and make a small unit, a 3 unit. And this is beautiful, because when I get done with it, I know exactly what needs to be done with these now. I left one of the plates out here so that you could see there. It's a 3. So what I did was, I made all these through it's a hollow center. There's a hollow center here, okay? So that I can actually bring air, or what I'm thinking is plasma H3, hydrogen plasma in here. It's a little bit of ways from it, but I've figured out how to do it, because he told us in 144 we gotta grow it. We gotta grow the hydrogen. We gotta have a feeder down here, and we're gonna have a way to. I already worked. I know each one is going to have a thing inside these pipes, because I can seal it inside, because I have a way here. Anyway, these openings here have to have the Coca-Cola bottle that comes out, that has the hydrogen that is being grown in here. So say this would be my CH3 um, leg. And when you make CH3 here, when you make CH3, all you really need is a wire and a nano-coated regular iron wire and a nano-coated and a non-nano-coated wire. So I'm going to put each one in here on our stranded wires through here, and then in the feeder tube here, it'll be caustic, it'll be aluminum, and it'll be salt. So that this will be the agitation point, which will feed up through here. These aren't the I already showed everybody how to cap the inside of these tubes. So you'll have a holding tube, and then once I get the Coca-Cola bottle to come out here, then I'm going to feed it back down into there, and then eventually the feeding of the plasma CH3 will be right here in the center. It's a lot of think process, and I've thought it all out, and it took me about 3 weeks to do, and I'm getting there. But I sound crazy talking about it right now, but I don't know if it makes sense to anybody, but you'll see as time goes on.
Makes good sense. Thank you for
So,
explaining that.
Mr. Go ahead.
I was going to say, be careful with the caustic and aluminum. If you put very much in, that's going to create the hydrogen gas inside, along with the air environment. So it'll be very explosive, let's say. So
well, that's exactly what I thought was because of that fact, and I won't use that much. But you need this to be the agitating point down here. This is where you have to have some sort of way to, in order, and hydrogen, we have to have a way to collect it and store it and use it and push it all naturally. So if you have it at the lowest point between all these 3 reactors, and you make this is my thinking, make this the agitation point where the hydrogen actually has to flow up through the pipe. And this is the overflow here, because these are all capped in areas here. Both of these are capped inside. Okay, so, and there's a cap here so that I can actually add solution in. And there's each one will be a capped off area so that you don't have to worry about any 4 of these touching. So that once the feeder down here, the hydrogen feeder starts to come up through here with my wire, I'm going to have a 12 gauge wire and a hole out to each one of these. So say I need to feed CH3 here, or CO2 to this one, and I need to feed CuO to this one, and CH3 to the middle. Each pipe is going to be a feeder for each one, just like the small ones here. We need a feeder for each reactor, and the pipe is going to be a feeder, just like these are being made. I'm going to make the feeding in the pipe, just like Mr. Keshe said a long time ago when I first showed him these. I went back to the lesson that we had, and he said, well, someday you're going to learn that these are going to be your feeder tubes. And it took us a long time for me to figure out what he meant by that. And now I know that these are going to be the battery, or the actual energy that's going to give, and then the hydrogen plasma will be in the Coca-Cola bottle. So now that the Coca-Cola bottle is here, because I got a fitting that's going to make each one will have a Coca-Cola bottle out the side.
Yeah.
So once the action starts here and rises through I need copper. I need zinc. I need iron, and then the fourth one will be for the middle, which will be a combination of all three, because that's the completion with the lead and myself from the fourth one. So 3 into 4 makes that combination work. So with the Coca-Cola bottle being here, with the hydrogen being built up from the feeding tube, I need to actually relieve that bottle of hydrogen somehow. So I want to put this is hypothetical because I don't have all the parts right now, because it came all to me in the last couple of days. So if you could just imagine a Coca-Cola bottle, and I'm going to put the tube here, it'll run back through and back down the leg, come down here, and the hydrogen tube will be fed here. And I'll have each one of those with the hydrogen plasma being fed into the middle. And you ask yourself, why do you want the hydrogen plasma field in the middle? Because these two rings are going to be wired into the middle, and that's where your power, that's where everything's going, is into the center. And then like the earth, your north, the north pole and the south pole do their thing, bring the energy to the equator of our earth, which does its thing in the middle of our earth. That's it. Everything has to be brought to the middle. So with the energy of both rings being brought into the middle, and then the hydrogen, the CH3, being brought into the middle, I figure will actually start to bring the rotation. That's my hypothesis.
Nice thinking, Mark. I like the way you explained that too. Thank you very much. That's really cool.
Thanks. That's what I'm working on. So we'll see. It'll take me about another probably a week or two, to get to that point. And like I said, I'm still working on this stuff. And then I still got all my GANs up top. I'm really enjoying the GANs process here, because a couple of weeks ago I told you that when I first started making my GANs, these GANs here, with the containers that I had, I started getting mold in them. On the very top, if you didn't keep the water level all the way to the top and you started to get a little bit of humidity or evaporation, black dots were starting to be created in the very tops of each one of these. So I didn't like that. So then I threw away all my things, all my GANs, like I said a couple of weeks ago, and I started nano-coating all my containers with the heat process of in my roasting pan. I take the water up to 180 degrees. I got caustic solution in there. I put my I have a thing that takes a vent that takes the air out, but you don't want to get your face over that heated caustic because it's a vapor. So I put I put a gas mask on to make sure that I don't inhale any of those vapors, and I have the fan on. So especially when you do these, because there's a lot of oil, and the plastic is made with a lot of oil products, you can really, it's like oily smelling, but it gets rid of it, and it negates all the I was worried about when they send these things to the landfill, they put starch in them, and I boil the starch right out of it. 180 degrees, they say starch is gone. Bye-bye. See you, Mr. Starch. And it just makes the plastic a whole lot more durable. And now I've had these for 3 weeks now, or since October 20th, and I've got no sign of mold whatsoever in any of the containers. So I don't know if that makes a difference or not, but at least I feel like now the caps the cups, the containers, everything I do is in a nano state. Everything. Everything you touch right from here, when I started this process and these guys here, all in a nano state. Hose, nano. I put it in that hot caustic solution 3 times, boiled it up, made sure there was no negative yuck in it, whatever man-made. I think that hot caustic solution, that hot, negates anything that man could do to it. And this is my 3rd run now on these containers and it's just the GANs it's making out of these containers is just beautiful, absolutely beautiful. This one here, look, I don't know if you can see it. Can you see the difference between these two? I mean, they're just, this is CO2, and look at how big and fluffy this one is, and look at how tight and so fluffy that one is.
Yeah, definitely. It seems like the one on the right would be more of the CO2 GANs, and one on the left maybe more of the zinc oxide.
And both of them have zinc plates in them. There's no copper in each one. They're all zinc. It's zinc, nano-coated zinc plate, and a nano-coated and a non-nano-coated zinc plate. Both of them. No difference. Same amount of salt in all 6 of them. And each one of them are completely different. And I don't know if I can get close enough to look at it, but all definitely. 6 of them are completely different.
Yeah, interesting, eh?
Yeah. I mean, this whole process is all about observation. And before, when I first started these containers didn't do this. And now by the 3rd process, I just rinse them out. I just, clean the salt off of them, and I start over again. And this is the 3rd run. Like I said, number 1 was up here. This one was number 1 run out of these containers. This was number 2 run, and now this is number 3 run. And just, I mean, the CH3 on this one is this high. There's got to be at least, I want to say at least 3 cups of GANs in there. And this one here, like I said, the CO2 on this one is real salty looking. Oops.
So, Mark, the fluffy white, is that the zinc or is that the CO2?
They're both zinc plates. Zinc, all zinc. I don't mix copper with zinc. I know we should, but that'll be the next time. These are all just pure. Everything's the same. Like this is copper pipes, like we did Denny or Lee when we cut the pipes open and split them and just open them up. This was just non-nano-coated with nano-coating. Same thing with the zinc plate. Zinc, I just nano-coated a zinc, this stuff here that I got from Home Depot or wherever, the big box plates.
Yeah, that's what I used to.
So I just would take, I just take some of that off, about that much. I roll it in half like that. I make a floppy over it and on the back side. And then this one, in one of them, I just take and put in my caustic solution, in the heated caustic solution, and it just bubbles up like a son of a gun, and I put it out and I rinse it, and I nano-coat it about 3 times, and that's what's on the back side of that one.
Yeah, I just made a batch up with a carbon rod, and then I rolled the zinc plate there into the carbon rod shape, and I just stuck them into the salt. And I had the white fluffy stuff on the top of the container, and more of the gray stuff on the bottom of the container. And I was just it's not clear in my mind which is CO2 and which is zinc, because I got 2 different things in the pot.
I can't tell you either, Lee. We've been doing this for a year, and seems like every run is different.
You say that again.
I try to keep it as consistent as possible. the same amount of salt, the same amount of water, the same area, the same air. I don't use any electricity. I just use the air pump. It's funny, this one here, all 6 airs start out at the same equal pressure. And this one here will shut itself off constantly. I have got to go and keep on turning the valve more and more. And the CH3 gathers around the valve and shuts itself off. Why it does that, I don't know. But for the last since
Maybe it's because blood coagulates.
because I started this project at 10:20, and what is it? It's November 8th now. So I've been working every 3 days. I got to put a little bit of water in. I go like, why is this thing shut off again? And I got to actually take the hose, pull it up, and make it the opening more. And each time I do it, there's more and more at the air valve. You know what I'm saying? There's more and more GANs, or the CH3 is just all over the valve. I could pick it up right now and you could probably see it. It would.
It's a good observation. I think maybe it is related to coagulation of blood in a way.
It only takes what it needs. Some days it's on strong. Some days it's completely off. Some days it's like, it goes like blip, 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 blip. So this whole, everything we do is observation, and I don't know. I don't want, I'm sure there's other people that have stuff that they want to present or show. But I have one more question to ask people, and it's now it's a health thing. Has anybody familiar with poison ivy?
Yes.
Yes.
Well, I get it all the time. I've had it since I was a kid, and year after year. So I helped my friend this fall do her bushes and stuff, and I got poison ivy, and I got it 2 weeks ago. And the point of impact, like I said, I did it last 2 Saturdays ago, and today's Tuesday. So last Saturday is Saturday behind this Tuesday, 2 weeks ago. So I can't remember, but for my own personal thinking was at endpoint or impact, where I get it the first point, it would take like 2 weeks from start to finish to get it and go away. 2, maybe 3 weeks. Is anybody with me on that? Because once you get it, once the point, you realize where it's at, but it spreads because you touch yourself in a couple different spots, and now you got poison ivy on your arm, and now on your thigh or leg or wherever, right?
Yeah, big welts all over. Yeah.
Yes. So me, here I am. I got this stupid stuff. I get this. I call it the stuff every year, and I got it, like I said, 2 weeks ago. There's the point of impact right there. Okay, can you see that the healing process? I've been putting CO2 and CuO on it for less than almost 2 weeks. Now you can see all the little red bumps, here and there, but this was the point of impact, and it's almost completely healed, and there is no itching whatsoever. And I can show you the point 2 was like my side here. Oh, there. They should have just exploded on my side. If anybody knows what poison ivy does, like I would have laid like this sleeping. And this would have been the point of, so this part here should have been at least as big as this. And it's not. and there was very little itching because I put CO2 and CuO on it maybe 3 times a day. When I, like here, I really realized it. And I went, oh man, what am I going to do? I got poison ivy. Oh, this is terrible. And believe me, you know how poison ivy gets. You're like so itchy, you can't stay up, you cannot sleep, you can't touch your. And when I put it on, it was smooth. It was like very soothing. And then there would be times like right now I can feel like one little spot that's it's a little agitated, but if I put some CO2 in the my solution, a little bit of that, boom, boom.
I absolutely agree. The CO2 GANs is amazing for skin conditions. I have skin conditions that's like that, but it's just due to my allergy to oil. And the same thing, I put on the CO2 GANs. It's just like it cools and draws away all the inflammation. And yeah, you get a peaceful sleep because you can not have to go through that severe itching thing, which when it was bad for me, it was one of the worst things in my entire life that I had to go through, actually.
And I mean, like, as a kid, you put on that calamine lotion and all that pink stuff, and it would just like get everywhere. And this time I said, I'm not going to do any of that. Let's put a little CO2 on it. Like I said, I can't even imagine this from in-point pack to now. It's already past the healing point. The scab is gone. There's so little left that it was like, what happened here? I should have poison ivy for at least another 3 weeks.
Yeah,
so I don't
amazing.
know. So,
right on. Thank you for that testimonial.
Okay.
Questions,
Thanks, everybody.
Mark?
I
Mark.
got something to share.
I got a question for Mark.
Okay, a question for Mark first.
Yeah. Yes.
Have you GANsed your poison ivy?
Pardon me?
The plant, have you GANsed it? The
Did I
poison
make
ivy?
GANs of the poison ivy?
Yeah, why not?
I actually made GANs of saffron that is actually supposed to help your blood, to purify your blood. So, no, I did not make GANs of poison ivy. I wouldn't know what the purpose of that was. I would be afraid that it might enhance the poison ivy to the point where it'd be overpowering.
Right.
Like I actually made GANs of my grass outside because I had some bad patches, and I actually used the GANs of the grass that I accumulated, and it cured the patches.
That's a good one.
Do you think that you making the GANs of the poison ivy would act as a vaccine against it? Is that your point?
That's my point, yes.
I don't know.
Don't know. It might work in a homeopathic manner if you had just the right percentages, meaning a very minor amount that would work on a atomic basis rather than the actual molecules and stuff getting involved, perhaps. I don't know. That's a tricky one. Maybe be a good question for Mr. Keshe is. Are there uses for GANs of things we're allergic to, for example?
Yeah, but here in Norway we have GANsed everything. I pick all the herbs, and I've got a friend who's GANsing everything. So
what do you do? What do you do with it, though?
Yeah, what do you do with it? See, I made this GANs here because actually, if you look up on Wikipedia, that this is the GANs of saffron. And I wear glasses, and I didn't want to go out. I don't want to go buy another pair of glasses. And they said saffron is supposed to be very good for your eyesight. It's supposed to heal, and it's supposed to take out any parasites, and it's supposed to clean your blood. So I went to the grocery store and I bought some saffron that comes in a little tube. I don't know if you know what saffron looks like, but you can get it from the grocery store. and that's what it looks like. It's just a an herb that they use to cook with, and it really made it was beautiful when I made it. It smells delicious, and I take a little bit of it every day and I rub it on my eyelids, and I take a little bit with my CH3. I've now learned now not to take CO. I take just a little bit of CO2 with my CH3 internally, but I don't take a lot of. I don't because I don't feel like I'm sick right now, so I don't take any CUO in my internally. I take I think that CUO is an external thing that should be used externally, and CH3, like Mr. Keshe says, is a thing that brings everything inside of us. So CH3 should be the drawer that brings everything from outside inside. And if you're sick, then maybe use a little bit of CUO. But CO2 is just for your emotion, but you don't want to overdo the emotion thing because you don't know which way your emotions are going to go, because you don't want to, you just want to keep a balance there. But the CH3 I think is more important. And then I use some other food GANs that we're learning about, like the sopal, the sour sop, and the cocoa and the shea, and now this, and just a few other things, just to be kind of cautious about making food GANs, because food GANs, you got to remember, have proteins in it. When I started making sugar GANs with sugars, maples, your from maple syrup and honey and things like that, that's where the molds start coming in. And you don't want mold in any of these things, because then you're starting to ingest them. So once again, I was worried about mold in my GANs from the containers, and then from the things that you start to create. So you got to kind of watch mold, fungus.
For maple syrup, as an example, if you were to have maple sap, then it'll tend to go moldy over time. It'll go off, and but if you have maple syrup that's of just the right viscosity and the right sugar content, then it'll keep for a very long time without exposure to air. Once it's exposed to air, then it starts to oxidize again, and you have the potential for mold there again. So yeah, it's interesting that you noted that with your. Now you're using distilled water, right? With your when you get that mold, it's from using distilled water in your.
Well, I started out doing nothing but exclusively using the distilled water. I was like Denny, I was buying 30, 40 gallons at a time. But then I started realizing that, using the method of just letting the water sit with the nano-coated copper on the bottom, and just siphoning off the first 2 or 3 gallons off a 5-gallon bucket. I thought we agreed that would be the cleanest, and the water's already started in a nano state, by having the nano, like I have these. I don't know. I don't know if we ever agreed on it or not. I don't know
I think
how.
I'm pretty sure that if you use tap water, there'd be a much higher chance of bacteria growing in it compared to distilled water, because they try to kill the bacteria with the chlorine and so on in tap water, or if you're on a well, then they have filters and so on. But there's a pretty good chance that there's lots of bacteria in tap water, as well as other elements that the bacteria might want to munch on, I'm thinking too. So
The copper nano, copper wire, nano-coated wire with the pipe in the 5-gallon container wouldn't kill that.
well, it may or may not be enough surface area, depending on the surface area and the amount of bacteria and the conditions and so on and so forth, and the type of bacteria. And the copper doesn't necessarily kill everything, otherwise it would kill everything, and that wouldn't be such a good thing. Perhaps some
So
bacteria
in the distilling process, the heat would be the killing process of all organic matter.
Well, the heat and the vapor process, so that with distilled water, you have a vapor that's pure. Just the pure water is vaporized, not the bacteria and other viruses and stuff. Is the idea under ideal circumstances.
Yeah, I can just say one thing. My friend has about 200 GANs, I think, about now, and she hasn't had mold on any of them.
I have 250 by now. I just want to add something about the herbs, because like the saffron, almost every herb has a health benefit when you look into it. So it might be good to have them.
Most definitely. What do you know about saffron?
Not that much, but I have done ganses from saffron too. So
Do you keep your ganses in a plastic or a glass container?
both. I have some in glass and I have some in plastic.
And in your glass ones, do you have with a metal lid?
Yeah, but I take some plastic foil over the lid, underneath it, so I don't have a contact to the metal.
So you use the plastic cellophane to keep it from touching.
Yes.
That's a good idea.
A good weekly hint, basically a hint of the week.
Yes.
Tip of the week, or they call it, or something. That's a good one. You could use, like mason jars and so on, with not have any contact with the metal lids. I guess a lot of the lids are already coated too with mason jars, but still, that extra layer of plastic seems like a good idea.
Well, just to try to protect ourselves from that cross-contamination. Because once you introduce that into the GANs, then you don't know what you have.
That's
you
right.
know, what was the content of the tin or the rubber or the sealant, or that could all leach in. And does silicon from the glass leach into the GANs at all?
Well, that's a good question, especially if there's caustics been used with the glass, then it'll tend to convert to the silica, I believe, or
Yes.
acids.
So if you don't get all the caustic out of any, in your rinsing process, then now you have a problem with the leaching of the silicon from the glass into the, at least with the plastic, we know that the CH it's a carbon bond. If that leaches into the GANs, it's a carbon, right? If you clean that plastic up to the point where, I don't know, can you ever clean the plastic up to the point where it's usable? I don't know. Whereas with the plastic, at least Keshe said that it's a usable CH bond. Whether it's broke down in a lower form or not, it's still being transferred as the carbon bond. It's being broke down. Whereas we've never heard of, like if the GANs is in a glass, it's the silicon is being broke down. What property value does that have in this? And that was what I was worried about by putting my GANs in glass.
I think there's actually uses in the body for that same stuff that comes out. It's got some sort of magical properties too, but you're right. do you want it as part of your reaction is the question, I guess. Is it, and whatever is not necessary in the reaction is probably going to interfere with it. So we want to keep things pure as much as possible. And glass has a pretty good reputation for being generally non-reactive for things. That's why they use it for lab glass and that kind of thing.
Like
So
stuff like that. Right?
yeah, they call it borosilicate glass as lab glass. It's better for high temperature and extreme temperature changes. It can handle it compared to regular glass. Mason jars are sort of in between regular glass and lab glass.
Well, it looks like Lee's got something for us.
I was going to say, I saw, something else. I saw Lee had something come up there. What do you got, Lee? Let me
Well,
spotlight
this
your...
is my latest CO2 batch. We were talking about fluffy CO or zinc or CO2. This method here just has the carbon rod and the zinc piece of zinc rolled up, the zinc roofing stuff rolled up into a rod, and it only sits in the water about an inch. And on this batch, I actually got some black stuff on the bottom. Probably came off the carbon rod. The first 2 times around, I didn't get any black. And then there's sort of a gray, and then on top there's the white. Now that pile of white there actually went all the way up to the zinc rod there before I just shook the bottle. So I think that fluffy white stuff is zinc GANs. So I just thought.
Current or voltage are you running in that?
I got, I don't know whether we can, I think I got 1.5 volts and 100 milliamps.
Oh, okay.
So anyway, that's my GANs station.
Interesting.
So I got some CH3 stuff on the go in these tall glass jars with a steel rod in it. And down the end there's my old method of doing the CH3 it's just got some steel bolts hung on, wired together and hung on the side with some nano-coated copper plates. When this CH, I got some with the carbon rods and some with nano-coated copper, and they seem to produce about the same. So anyway.
Right on. Thank you for showing us your GAN station there. It's actually pretty
thing
impressive.
I could show you is my plants here. They're growing like weeds because I put carbon CO2 GANs in them.
Yeah, huh?
Normally
they're spider plants, aren't they?
Yeah, that's what they are. Normally this spot here, it dries out and you can hardly grow anything in it. But as soon as I put the CO2 in it, they're growing like crazy, like they're a foot high. Normally there are little 4-inch things or something in this pot.
Yeah, I put CO2 in mine, and it sprung out one of those little stringers, and it just exploded at the end of the springer in a whole new plant. So now it's having babies.
Yeah.
So you gotta watch. You gotta watch what you're doing with that CO2 GAN stuff.
Yeah, that's the other one down there is growing real good too.
Yeah, it's got a baby there.
Lots of babies down there, about 6 of them.
Oh yeah, right.
Yeah. So anyway.
Cool.
Lots of fun.
They're gonna take over your whole living room pretty soon, it looks like, and they'll start reaching for the GANs and sucking on it at night and growing. You won't be able to get in to take over again.
Yep.
Such is life. It's tough. Tough being an experimenter.
Okay, that's all I got here.
Thank you, Lee. Excellent. Okay, I did see somebody trying to show something earlier, and they got cut off or wasn't able to show it. I don't even know who it was. Was it I don't know. I just saw a picture that something I didn't recognize. Someone was trying to show a reactor, a coil set or something. Would anyone like to show something?
I can just add something to the poison ivy.
Mm-hmm.
This is Willie. The stuff that makes you allergic is called like urushiol, and it's the plant's way to contain and get moisture, contain water.
Hmm.
So it might be useful.
Well,
Not a touch though.
could be useful, for example, in a plasma capacitor to maintain the moisture in the electrolyte or something like that, or a plasma battery perhaps even.
Yeah, that's what I thought. Maybe. And it might have some health benefits too.
Or maybe I could just put it in the bottom of my feeders, down in the bottom of my tubes, because now it just told me several times on my body, hey, we want to be part of this.
Yeah, that might be it.
And now you just told me that it's a moisture retainer, and that's exactly what we need is something to bring water into the reactive stage of this.
Yes,
So
and
if I
it's
had an open container, or if I had a container, which I once I'm done, there'll be an area where actual C or H or H2O will be able to penetrate my pipes and be able to actually get down into it. So now that you're making me think of this, that if that's what it does, maybe that's the reminder that I needed to add to the bottom of my reactor.
Maybe.
might just be, you know.
You never know. I'll have to put a thought to that.
And it has a, you're welcome. It has a interesting bond too if you look at the chemicals of it.
As we all sit and ponder.
Yeah, that's a good one.
It has got I don't remember exactly what it said, but 15 or 17 alkaloids. Yes.
Hey, so these car units are supposed to completely nano-coat the inside of any vehicle, correct?
Maybe.
Maybe. Well,
If they're working correctly and everything is correct, I guess that's the basic idea.
Okay. Well, I was thinking about the way that y'all were talking about attaching the wires. You know, where they would be like running magnetical or gravitational.
Mm-hmm.
And just so happened that, man, my wires they're really good nano-coated deep inside the wire, which is pretty impressive. I've had them sitting there for about a week now, but I hooked it up to a car battery, and I can feel the fields coming off of it. It's awesome. But well, what is the main purpose for these units? And what's the best way to hook them up? Should the ground be directly hooked, or the gravitational be directly hooked to the car battery, so the lead would act like a earth ground, and then the positive go directly to the positive terminal? Or should the the gravitational go to something more like a ground on the engine or the.
I think that's the way that Vernie was talking about, using the like the intake manifold, for example, as a ground place, and the whole engine block would be essentially the first thing to nano-coat, or the be the main terminal in a way. Rather than going through the battery, which it goes into the battery, then the battery has to connect to the engine block through a separate cable. So you would attach directly to that block through the intake manifold, or maybe through the ground on the engine.
Yeah, my understanding is from the guys in Peru, and from John was saying it there a week or two ago, that for now the best results are being had by connecting directly to the battery. They're gonna test connecting it to other places later, but they've been getting good results on the battery. So you want and John was saying, put the gravitational coil of your car unit to the positive terminal and the magnetical coil to the negative terminal. That's given the best results. I had mine on backwards to that, and I wasn't getting any results, and I've switched them around, but I haven't bought a tank of gas yet to find out what my results are. So,
and that almost sounds opposite from the way that that I first heard, whenever they were just making just a little coil, sticking them on the terminals.
Yeah, not sure.
Yeah, it gets a little confusing in that end of things. Suffice to say, just go with the current flow of information and do the best you can to keep up with that. It changes from time to time.
Yeah. Anyway, right now I've put them into 4 vehicles with that arrangement, and it'll be a couple weeks before I get any results back. So
you're going gravitational to positive and magnetical to negative.
That's what John said last week was given the best results. I think that's comes out of Peru, I think, where they're making them down there. So,
awesome.
Well, that makes sense, because the gravitational is the input of the coil. So you're going to go from the output of the battery, the positive of the battery, to the input of the coil, and then the output of the coil goes to the input of the battery, right?
No, that's wrong, because if you look at the current flow on DC circuits, it goes from negative to positive. The negative terminal has an excess of electrons, and it flows over to the positive terminal, so the electrons are actually going into the positive terminal. If you look that up on the internet, it's backwards to what we normally think.
Yeah, that would be the current flow, but is the plasma flow the same direction as the current flow?
Right.
No.
Right, it's opposite, correct? Like generally, a plasma will tend to be in the opposite direction of the electrons, the electron flow, or at least at a 90 degree to it, apparently.
If that's true, then that makes sense to put the magnetical on the negative, because then it's flowing the opposite, I think. Yeah, because inside the battery it would be going from the plus to the minus. So if we hook it up with magnetical on the negative, then it's going opposite direction from the negative to the positive inside the battery. So it depends whether we're looking for plasma flow inside the battery, outside the battery. That's where gets confusing.
Yeah,
flow direction is.
Mm-hmm. Yeah, if the fields.
I wanted to nano-coat my motor.
Well, the latest info is attach it to the battery, but they used to talk about attaching it to the block, so I guess you'll have to take a choice and try it.
Yeah.
I have to correct myself on the poison ivy. It's an alkyl chain with 15 or 17 carbons attached to it.
Okay.
Hi, Rick.
Hello, is that Alex?
Yeah, it's Alexz, Rick. You all right?
How you doing,
Don't worry,
Alex?
I fixed my internet, so no need for
Oh
any
yeah.
interruption. Yeah.
Okay.
I'm just wondering, has any of you tried to make GANs of yourself?
Of
Yeah, oh,
Yes.
sorry. I
go
have
ahead.
made of my skin and my hair and my nails.
How did you do it?
Oh, I just take an example my nails and put them into a caustic soda solution and let
Okay.
it stand there for a couple of days.
Mm.
Then I take the stuff on the bottom out of it and put it into a CO2 kit.
Okay. But I know that other ways of doing it. I mean, a quicker way. You don't have to go through that long process. What you do is if you put some water in a bucket and then put some drops of liquid plasma in it and then add like a pinch of salt and then just put your feet, both feet in the bucket for a couple of hours each time every day. By the next day you have the GANs of yourself there. That all
Yeah,
makes
but
sense.
Hello,
sorry.
Alex.
Yeah.
I start out my entire process with my feet in Himalayan salt, heated Himalayan salt. That's how I start my GANs process.
Okay, if you add some liquid plasma to it, you make the GANs of yourself. And then what I do with the GANs is this. If I try to make those GANs when I'm happy or when I'm in a better mood.
Yes,
So that when
I listen to my favorite music and I put my feet in the salt water, and that's
Okay.
what that's what Caroline told us in the very beginning, is to connect ourselves with the very beginning. And the water
Okay.
that we use is the very beginning from when we start our GANs process, the very beginning. That's our start process. And I put my feet in the start process.
Okay. If you had added some liquid plasma, we'll have been able to harvest your own CO2 from the container easily.
What
You start saying,
the way I made my my own personal GANs was I took all my fingernails and my toenails and I put them in a container, and I used CH hydrochloric the stuff that's in our stomach, this HCl. Yes. And I broke it down that way, and then I put a couple of drops of my blood in there so that it would recognize. But see, the salt water from my feet is in the container. So now I have my fingernails, and I took some of the top of my hair, my hair from the top of my head.
Yeah.
Where's my thing?
I have a question.
I cut out hair from the top of my head, right here in the center of the core, and I did that in the whole process.
Okay. So what do you do with the GANs when the GANs of yourself? What have you been able to do with it? Like me, for instance.
I use I'll use that in my central core.
Okay, you don't use it for yourself.
For my soul.
You don't use it on yourself. Like for instance, if you're sick, for instance, if you clean the GANs of yourself and then you put it in some water, you add some of it to water, and then you put your feet in it, you're gonna see how you feel. The malady is gonna go away quick. Did you get what I said?
Yes.
If you're sick, for instance, just take the GANs of yourself and put it in some container, and then add some water, and then just put your feet in it. You're gonna see the feet is gonna balance itself back to the state that it was before you got sick. Because the GANs you made of yourself, then you were well, you weren't sick. So if you put your feet inside and add the GANs of yourself, the feet is gonna try to balance the body to the same feet strength that you were when you were making the GANs that you put in the water. Does it make sense?
Oh, yes, it does. But I'm not sick.
No. I'm just saying if you're sick and then you have any malady you want to treat, that is the best way to use yourself to create a balance for yourself.
Can I ask you, Alexz, again? You said put your feet in the water with salt water, and put some liquid plasma.
No, not salt water. Listen, not salt water. You add a pinch of salt to the water.
Okay,
and then you put
into regular distilled water with your feet in it, and then you pour some liquid GANs plasma water from what, CO2, for example, and then you're transferring the fields into the water you have there. Is that right? So you're not getting a GANs, you're just getting a GANs water that you can use. Is that right?
I didn't get that. Please, can you repeat that? The last sentence.
When you do that, you're not going to get a GANs. You will get a GANs water. You're transferring the fields into the water in the bucket. Is that right? Or do you get GANs?
Well, you get the GANs of yourself. You get the fluffy GANs coming. If I could show you, I know if I open my camera, I think my connection is going to be lost, so I don't have a lot of bandwidth. Otherwise, I would have been able to show you the GANs of myself I've done.
You actually get the GANs. You get CO2 GANs building up in the.
You get the GANs of yourself, like the CO2, the fluffy white CO2 things from the CO2 reactor. You get the same thing of yourself, and then you can even see the layers of amino acid on top of the container after a couple of days. If you repeat that for about 3 or 4 days, you see the amino acid right on top of the container. I mean, the surface of the water in the container.
So your 2 feet are acting like. Oh, sorry.
Yeah, the 2 feet as the electrodes and so on, like nano and so on. But it's like that. The left feet it takes, and then the right gives. So if you put both of them in the water, it's the same thing as using your electrodes. As long as you don't let the feet come in contact with each other, it's all right.
Right. Wow.
How long do you sit with the feet in the water each time?
Well, each time I spend like 1 hour, and then I take a break, and each time I have time, I just stay another hour or half an hour. But as long as you can do it for a couple of days a couple of hours every day, it's all right. Within 2 or 3 days, start. Even the first day, by the end of the first day, you'll be able to see some cloudiness in the water, and then by the second and the third day, you start seeing lots of GANs in the water. So if you're sick and then you want to bring yourself back to the condition that you were in while you did the GANs, you just add some of the GANs into a bucket a container, and then put your feet there and put some water. It's going to balance your feet back to the original state it was when you made those GANs. Am I making any sense at all?
Yeah, thank you, Alexz. Okay. It's interesting.
A question more. Can you only use that for yourself? Example, if I make GANs like that, can I use it on my mother who is sick?
I don't know. I've not tried that. I've just tried it on myself. So if I don't know if you can try that. Well, you can try to see if it's gonna work. I mean, it's the same field anyways. So you can try, but why don't you use your mom's, tell your mom to make GANs of herself.
Right, that might be better.
She is already sick.
Yeah, that's
It's a good
okay.
point.
That's cool. Yeah, cool.
And she does.
Sorry.
You would
I
have the
remember-
DNA connection there, definitely.
Sorry.
As the mother, there'd be the DNA connection, the amino acid connection. So maybe that would work within a family situation, where somebody that was in a healthier state could maybe help another family member that was in a less healthy state. I wonder. That's a good point, because normally we don't mix our personal GANs and amino acids and so on. Generally, it seems to help others and whatnot. So, but it seems like it might be appropriate in that case. Any other comments on that?
I think that will work. I think it.
So just to clarify again, you're going to use all liquid plasma or just a little bit of the liquid plasma
CO2.
in a CO2 plasma into a bucket of water?
Just CO2 liquid plasma. Well, if you can add some zinc oxide, depends on what you want to do with it anyway. You can add some zinc oxide.
But it doesn't have to be 100% liquid plasma. You can just dump a little bit into a bucket of water. Is that right?
Yeah, just some drop. Just sprinkle some drop in the water, and then that's all. And then add a pinch of salt. I think the liquid plasma is just to trigger the fields. After that, it just it doesn't do nothing anymore, because you start seeing your own GANs. It's coming to the container.
All right, thank you for that, Alex.
Thank
you for that, Alex.
Oh, thank you, Rick.
We've got. If there's no more questions for Alex, we've got Patrick, who says he has something he wants to share. Okay, Patrick, do you want to? What do you have to bring up?
Yeah, Rick, you need to enable me.
Oh. To start your video. Okay, there you go.
Cool. Hi. Yeah, look, I've just been playing around with the car Magrav unit, and I'm a little bit nervous. But anyway, so this is my car Magrav unit, and currently, my partner and I did a trip on Sunday, and we got 61% on the original car's output economy. And I just wanted to share the little subtle differences that I put into this Magrav unit that I think made a little bit of difference. Previously, I'd made like a cube, and I'd made a larger version of a Magrav, but this is the smaller version of the Magrav. And this is the one I got 61% from. And I'm just going to show you my phone. Can you see the center core here? Oops. We can see the center core, and you can see the.
It's hard to see with the light, but we can kind of see it the first time you had it there.
Hang on, just let me get the right picture up, hopefully. The center core's got little holes drilled in it.
Mm-hmm.
And then we put a coil around the center core. We wind a coil, don't we? What the trick is that I've drilled 2 holes and I put the end of the coil, I bend the end center of the end of the coil at 90 degrees to the coil and put the pin into the little hole there and seal the pin into the hole and glue it all up, fill it with GANs, glue it all up, and that seems to do the trick.
So is that one pin into one hole, and then you've used the other hole to fill, or is there 2 pins?
If I can just make my phone enlarge. No, it won't enlarge. But anyway, so we've got the spiral on. If we're going to the positive terminal, we're using the outside of the coil going off to the positive, and we're putting this spiral on the inside coil. Okay. So you can see the little pin down there, can you?
Mm-hmm. Yeah.
Yeah. Well, that goes into that hole.
Okay.
And that makes direct contact with the plasma.
Mm-hmm.
Okay. And then glue that into position. And another thing that I'm using too is a piece of copper end for
A pipe.
to blank off a copper tube.
Right.
And this is nano-coated copper. It's a copper end rather than a plastic center GANs holder.
Mm-hmm.
This is copper, and I just think these little subtle differences are helping me to achieve what I'm getting.
Mm-hmm.
Yeah. So I mean, the cars had plasma different. I've been experimenting for a couple of years with our car, but the cars had various plasma units on it for a long time. So you need to take that into account. But
Mm-hmm.
this has helped me to achieve some pretty good results.
Wow, that's
Just
pretty
by,
neat.
just by poking that little pin into the hole and immersing it in the GANs. So I don't know what anyone else thinks about that, but if you can imagine, you've got the positive and the negative inputs to the battery. Well, I'm mounting the coils on the end in the recess for this end cap. It's just a plumbing end cap, and sealing that in there. And then I'm putting another GANs ball in the middle between the 2 ends. So you've got your positive on one end, the negative on the other, and a GANs ball in the middle. So you've got 3 GANs balls in there, okay? And then I'm packing the center GANs ball with household insulation, and it creates a soft capsule for the center GANs ball to fit in. If I can just show you. If you can imagine this encapsulated in household insulation wool, but the household insulation wool has been soaked in GANs and then dried out. So there's lots of GANs in here, and this is suspended sort of midstream between these 2 ends. Does that make sense?
Yeah, it does, and it's kind of a brilliant idea actually in terms of suspending the GANs ball and
Yeah.
having GANs around it at the same time and impregnate it into that into the fiberglass wall. Mm-hmm.
Yeah. So I'll just get you the just so people that if they're not sure what I'm talking about, it's this fiberglass bats, the fiberglass insulation. Now you can easily soak this in GANs and just load it all up with GANs, and it's yeah it's quite a good medium to hold the GANs. So, and if you've got a little bit of patience, I can just show you what else I've been playing with. Can't see me. Here we are. I've got a tub full of water, and I've got different GANs balls in my tub, and I've got a piece of paper, and all of the GANs balls are numbered. Every one of these is numbered, and I'm getting different effects. Now, all of these have got just GANs water. There's no GANs, there's just plasma water in these balls. And the kind of effects that I'm getting, this is a neodymium magnet. Don't know, can you see that?
Yes, that's interesting.
And just some of these.
Can you pull it? Can you pull it back the other way? Can you pull it back the other way too?
Yeah.
Yeah, like
Yeah.
that. Wow, that's pretty cool. So is that
these,
CO2 GANs water inside that ball?
No, I've got different GANSs that I've made, and I've numbered them from 1 to 10. I've got lead, neodymium, I've got bismuth, I've got rare earth, aluminium, copper, CO2, CH3, acid, and I've got alkaline. Now, the two best reactions that I get with the magnet are from the acid and from the alkaline. This is acid, and you can see that this is just GANs of acid. You can see this isn't quite strong enough for it to pick it up, but you can see that. Am I focusing on it properly? You can see that the magnet is just chasing the magnet around any direction I go. So, and there's different ones. This one's got my DNA in it. Now, just from my DNA, it works better if there's nothing in close vicinity.
That's great.
You see, it doesn't. You've got to take it away from the wall surface of the plastic for it to actually. Can you see that effect?
Yeah, absolutely, absolutely. That's really cool,
And
actually.
just I'll come in from the other direction.
Yeah, that shows it's not just going downhill or something. Yep.
Yeah, there's nothing on my fingers to do it, you know.
Right. Nothing
There's
up
no
the
secret
sleeve.
gold, I promise. But that's actually from my GANs. I've got like a salt GANs that I made. That's highly alkaline. And I think that's around about 14. The alkalinity level's it runs at about 14, and the acid is about 1.2. And
What
they
kind
both
of acid is it?
sugar. It's derived from sugar.
Sugar.
Yeah. So and this one's just the standard salt GANs. So and I've got
Can I ask you how you made your 14?
this is just made with salt and drain cleaner. NO8. What is it?
Right, right. And
Caustic soda.
yeah, caustic solution. You just put that water and salt together,
Yes, yes.
and you created a GANs, and it was. Did you wash it?
Oh yeah, I washed it about 3 times, and so it's probably still got some salt mixed, some sodium hydroxide mixed with it. And I've got a pH meter, so I can tell you that that is what the pH is.
Yes.
It's around 14, and
After your third wash.
yeah, it's after my third wash, and since then it's been washed lots of times since, because I'm using this water quite regularly, so it's being replaced all the time.
Right.
Yeah, so there's just a little bit of GANs in the bottom, and it seems to keep the alkalinity level to where it should be.
You keep replacing the water with distilled water, and it stays at 14.
Around about 14, yeah.
And does your distilled water come in at like 6 or 7?
Yeah, roughly 6 or 7, yeah.
So when you pour it off, and you just pour it off, and you put your new distilled water in it, out of your container, it keeps it at 14 or 13.
Around about 14, but you need to
Even
leave
if
it
it stayed at 11, even if it was 11, when you put that in there, it stayed that high.
I haven't, to be specific, I haven't checked it. I would guess that
I try to watch my pH in all my containers, and I try to take a reading every 2 to 3 weeks.
Yeah, yeah. I would loosely say that it's 14. So last time I measured it was 14, and I would loosely say that it would be about the same now. And I probably measured it about a month ago.
So 30 days out.
Yeah, probably.
Okay, that's cool.
But this is the acid. Sorry, this little ball was my DNA. This little ball was with a spot on it, was my acid. I've got an alkaline one here somewhere. I think this was the alkaline one. So
it's very nice that somebody actually takes the time to label and do the due diligence.
Well, I must admit, when I first started, I was pretty eager, and started this experiment a little while ago, and some of these balls were for my spinning reactors, and I must confess that I lost track of what was what. So, but I clearly number them all now, so there's no mistake. But yeah, anyway.
Well, no, you're doing a wonderful job. Just because you've taken us farther than we've been before.
Oh, cool. Thank you.
Yes,
Yeah,
thank you,
I just
Patrick.
thought it was really interesting that I could make with my DNA. This is my DNA.
When you are saying your DNA, do you mean your blood?
Well, in fact, my DNA, and I think someone else, because I came on fairly late. I've only been on for a short time, and this is my first time ever. But this is my DNA, and it's a mixture of my blood, and it's also toenail clippings, and yeah, so it's probably looks a little bit gross in there, but it's definitely me. So, but this is, I'll just show you again.
Seems you have to check the live stream, Rick.
Can you see that?
Somebody says it's not working.
Let me see. I'll check the site.
Just say a word, Patrick, and then we get you on the big screen.
Do I need to redo that?
Patrick, actually, I think you're more lucky than the rest of us to find that container that you're doing it in. We don't have access to a plastic container like that, and it might be more harmonious to everything that we need. And you know what I'm saying? Like, that's a perfect environment for you to make that happen.
Can you see that?
It's awesome.
Yeah, it's pretty amazing. Pretty amazing.
I haven't worked it out if it's my intention or if it's the DNA. So, but just have a look at this. I mean,
Wouldn't you say it's more the magnetical field between him and what's in the ball?
well, this is my DNA, and there's not a huge magnetic field here. This is a neodymium 52 magnet.
Yeah, but the magnet is making a field, and you're connecting the ball to the field, and you're
Yeah, but the magnet's over here. I'll put the magnet over here. It's got nothing. This is me.
yeah. But what I'm saying is your signature of the magnet is still on your hand. You know,
could be.
Yeah.
Could be. Well, let's try the other hand. Let's try the other hand. I don't know. It's coming over. I think after a little while it builds up momentum. But if I could just show you this once more. Where did I put the other ball? Oh, here we are. I don't want to pick up the magnet with my left hand.
You got to remember your right hand and your left hand are one's giving and what.
Yeah, but this ball here has got acid in it. and look at the acid chase the magnet. I can almost lift this up. I just thought it would. The reason I did this was because I'm trying to correlate and trying to build a picture of my different GANSs. You can see my different GANSs. I'm trying to build a correlation on what GANs works with what, and so I can make a combination for a purpose,
Well,
and so I can purposely orientate a GANs for this, that, or whatever. So I don't know if I'm barking up the wrong tree, but it's good fun trying.
You know, it seems to be exactly what we should be doing, is trying to catalog and figure out what combinations are appropriate for certain things, and yeah, I think it's great you're keeping track of this stuff and having successful experiments there and so on. Yeah, do
finally somebody that wants to keep standards.
and does pH checks, which you've always been so it's been important in your life, Mark. Now
I'm
you have.
sorry, Rick, but if we don't start with basics, we don't have anything to.
Well, you're absolutely right. Yes, and yeah, we should be all standardizing with pHs and so on, just as a part of our regular routine, as they would in any decent laboratory and so on, to try to standardize things as much as possible and to look for results that are outside, or anomalies that are outside the normal, like what we just saw from Patrick there, which is really good stuff.
So just to cap off, fill this with insulation and make a nice little cradle for the GANs ball to sit in the insulation, so it's nicely padded. But have the insulation saturated in GANs and just leave it out in the sun to dry. So we've got lots and lots of GANs in there with a ball, and you can try different GANs. You can have a different GANs in the ball as to what's in the insulation, as to the GANs that's in the end cap. And I think neodymium's quite a good GANs, and you can do all sorts of things with the different GANs, and Mr. Keshe talks about torsion, gradients, and so we can all play with that and get some really good results hopefully.
Very good, Patrick. Thank you so much for sharing. It takes a lot of guts to get up in front of the public, because now it's your face is out there along with the rest of us. So thank you very much for.
I'm sorry, world.
No, thank you so
Patrick.
much.
You did a wonderful job. Wonderful.
Very excellent.
Yes,
That's
you,
exactly what this group should be doing. It's what it's for, is for new people to show up and do their thing. I say new people, but you've been at it for quite a while, obviously, and this whole GANs thing has become very routine to you after a couple of years of working with this stuff. So you've been out there. I haven't heard from you. Go ahead.
We have our meetings, Rick, on a Monday night. That's the Australian Keshe Foundation. That's on a Monday night.
Oh, it's Australian. I'm sorry. I thought you were in England, maybe. Okay.
No. Every Monday night at 7 p.m. Eastern Standard Time, and I guess everyone would be welcome. Yeah. Anyone's welcome. So.
Right on. And are you part of the admin of the group and whatnot?
No, I'm not. No. Just me.
An avid member. Right on. That's great. Thank you very much. That made the night here, I think, to see that.
I got a comment about the acid and the alkaline, if I may.
Mm-hmm.
We tried it with the patches, and you will, if you try it with the patches, you will certainly feel the difference. Just on the CO2 or the zinc patches, just try it with some alkaline in one and some acid in the other, and then you will see the difference.
Okay, good point. Makes me wonder whether we should be using alkaline or acid as a particular method.
It doesn't have to be much, you know. A little of bicarbonate in one and some vinegar in the other.
Mm-hmm. Don't mix them both, or your pad will probably blow up with the gas.
Maybe, or just fly away.
Last result.
Well, we just like to say thank you, Patrick, for your input. We appreciate
It's my pleasure, because I've been listening to this group for a long time, and I always get so much out of it, and I felt like I wanted to return something. So
Very, very good. That's exactly what it's all about, and you're certainly welcome to come by and share. Please do come by. In fact, I insist you come by and share your stuff with us. More about your pool of wonder balls there would be cool to notate that more and play with that more. I think that's got some really interesting things. I was going to do something similar. I've got a little wading pool. I think it's 4 feet. It fits on my green table back there just nicely. And I've got these other big glow balls and plastic balls and so on to float in it. I was going to see how they orientate themselves and how the fields want to position themselves through positive positioning and whatnot. So that's another project of many that need to be completed. Okay. Are we done with Patrick yet, or how are people?
Can I ask him a question?
Absolutely.
Are your balls nano-coated or not?
Some of my balls are nano-coated, and some of them aren't, and I've lost track on which is which. Having said that, I've got a 3D printer. I'm lucky enough to have a 3D printer, and I found it difficult to retain any fluid inside of the 3D printed balls. And so what I ended up doing was this. Painting them with a lacquer, just to retain the fluid, because I've got all sorts of things that I've made. Actually, can I show you some more?
Sure, go ahead. We're going to wrap things up soon here, but go ahead. We're on a roll.
I've got some. I've got some little 3D printed holders for my coils. And you can see that the idea is that I can rotate these to either have them flat or at 90 degrees.
Mm-hmm. Nice.
And what I do inside of these, not these particular ones, but I've got a little dome that goes inside of here, front and back, and that's little dome is for my GANs ball. And so I found that I had to lacquer all of these domes for it to retain the GANs and the moisture. So
Patrick, did your 3D printer make that axis from the the
yeah,
360 yes,
yes, yes,
that's
yes,
beautiful.
yeah. So that's just a little. I had some help because my 3D my um my skills with drawing up a program like this, an item like this, are somewhat limited, but I'm getting there. So
Yeah,
a
yeah,
friend of
but
mine,
see, the nice thing is the center piece of it could be a free flowing, if that's the problem is like in a natural state, the center piece has to be a free flowing particulate. And
yeah, yeah.
you know
If
what I'm
I
saying?
can,
So if you could get rotation in that middle point as an axis like a bearing, you know what I'm saying, is that I'd like to have my Magrav middles be able to flow freely. That's
see,
beautiful. Yes.
see
Once
this,
you get the rotation, and that's why I wanted the plasma buildup to push that.
this is the larger. This is for the household Magrav size, and this is a small one that I've been working on, and this has all been nano-coated inside and out, and I actually mixed up some glue. If I can just show you the glue. I guess we don't want brand names, do we? But we've just got a PVA wood glue. And this has been painted with a PVA wood glue mixed with copper GANs. Okay, so mix the glue and copper GANs together, and then you can apply it to any surface you like.
So you're trying to get the GANs to stick to the surface.
Yes, as well as well, you can use a lacquer, mix the powder of the GANs with lacquer, and still achieve the same thing, a GANs packed coat.
How do you what's your thought process on trying to connect the GANs? See, now that you have the GANs on that material there, that whole process, well, do you know which GANs is on each of the materials?
This one's CuO, because you can tell by the color too.
So you put CO2 throughout the whole process.
No, this is CuO, copper.
Oh, copper. Okay,
Yeah,
okay.
this is copper, but I've done them with CH3 as well.
Right, so it would be a red.
Yeah. So you just, if you've got any kind of like a urethane coating or something, you've got to dry out the GANs, and you can mix it with the urethane or with like a PVC glue, like a wood glue.
Yes.
And yeah, every little bit helps, I think.
So just let me ask you this. So, because you're very very thoughtful in your process. And last week we Armin, do you know who Armin? You know who Armin is?
Yeah.
Yes. So in your thought process, how does the fields come out of that once you seal it up? You know what I'm saying? So you're using the wood bond, or Lee uses the epoxy, And like Armin said, once you seal the like Lee puts in titanium GANs, and he uses, and he hopes that encapsulates all the properties that are the material or the field. That's, so what I'm saying is, how do you get that, what you want, out of what you're putting out? You know what I'm saying? How do you get that out?
Look, to be honest, I just do my best, and I don't know because I'm still learning. But
yes, of course, we're all still learning.
And I think I'm just going through my own intuition that tells me that that plenty of GANs is better than just a little bit. And so that was the theory behind it. The more GANs, the better.
Oh, I agree.
And it's not only quantity in this case. It's actually you're putting a very thin layer on that structure. It's not like it's over gansing it, really. It's creating, and it's the thin layer that's where the action is. I think that's where the real power of the GANs is and in the nano coatings too, perhaps, is in the thinness. They have a whole technology called thin layer technology, and using different types of materials in thin layers, where they work in thin layers, but they don't necessarily work in a thick layer. But that's a great way to put it on with the polyurethane. It's great.
Just something else that I'm hitting. The 3D printer is pretty handy because I'm in the process of making some new balls, and these spin quite well. Some of my earlier models didn't, but these are spinning quite well. And I'm getting these up to about probably about 15,000 RPM. Yeah, and they're spinning. They're a little bit noisy at that speed, but it seems to do the trick.
Right on.
And I've got various balls that I've been spinning.
So are those the balls themselves you didn't make in the 3D printer, did you? Or
this one I did, the center ball in that one. You can see the color. It's a washed out color blue.
Right. Okay. Mm-hmm. But
this one,
not the clear ones, though. Eh? The clear ones are bought.
This one's got this one's got 3 balls in it. This has got nice. 2 clear balls and a 3D printed center ball.
I see. And the clear balls, what are they made out of?
Oh, they're just spheres, just the
acrylic
ones you buy from China. Yeah.
Acrylic. And but you haven't spun them up to like 15,000 RPM or anything.
Yeah, I have.
Oh, really? And they haven't exploded. That's amazing. I guess it's the. Go ahead.
I've got this is made from PETG plastic.
Mm-hmm.
PETG plastic.
Mm-hmm.
And that's actually very strong. And if you can see, I've taken this up to the halfway mark.
Mm-hmm.
And it lends a lot of support to this center ball. And
right. It prevents flexing, especially because they stress crack and break rapidly. Then.
Yeah. And I do it in a container because I've had a few balls let go on me. And
Patrick, could I ask you, the guy that's writing your program to make those, could he put a, like when you make that bottom, could he put on the inside acrylic part when you spin that so that you could have a twist? I don't know how.
This is the only one I've had help writing with. I've written these.
Okay, so what I'm asking you is, could you write a program to twist the top and the bottom together? You know, like like when you spin
With threads, you mean threaded?
threads. Yes, thank you, Rick.
Yeah.
Could you write it so that you could put a thread, 3 threads on the top and 3 threads on the inside?
I'm not sure, like on this part.
Yeah, so the stem
No,
of it.
he means the part where your other. Oh, you mean on the stem, or you mean on the middle of the ball
middle,
part?
Rick. You know what I'm saying, Rick.
The bigger diameter where your other hand is, Patrick.
On here.
Yeah, right
Yes.
there.
Yeah, oh yeah. You could actually. The plan was. Get up some more here.
He's got more, folks. He's pulling things from the back to delight us.
The plan was to be able to spin the ball and reduce the size of the top one. So you've got a narrow window around this edge.
For observation. That's your observation window.
Yeah, but that's a little bit further down the track. I can spin these up to around about 15,000 RPM.
Well,
like that.
My question to you is, since you've been able to create each one of those, could you put a thread so that you thread each one, you know, because a thread would be either counterclockwise and into each other so that you would twist them into each other.
I don't know if my capabilities would extend to that, but I could get someone to do it for me, yes.
You know what I'm saying? So that would, because once you had that thing spinning, and even if you had that middle observation where you'd like to see, at least the parts would go together as a thread. You know what I'm saying? So that it would be tight. Instead of gluing it together, it would be threaded ball.
Right.
Or
yeah, and you could put the observation ports in different places other than where the threads were, basically.
Even if they were just peekaboo holes.
Mm-hmm.
Yeah. Mm-hmm. But you see, this was an attempt, but I've made this come down too low. I need to reduce the radius on this, so it sort of comes down to enlarge that window to probably about 25 mil.
Not even that. If you just left that a whole sphere and you just wanted to see what was going on inside of it, all you'd have to do is program 3 centimeter holes to look inside.
Yeah. I've had a couple of balls spin off and just disintegrate, and I'm not that fast, so I've had to duck pretty quickly. But on one of my center balls, I've got a little pair of scales, and I know what the weight was before. The disadvantage with a ball that's not clear is you can't tell if it's got fluid in it. Mm-hmm. So I weighed it, and it was empty partially empty after I weighed it, and I couldn't see any evidence that the plastic had been breached. Mm-hmm. So that's where I'm at the moment. So.
Yeah, we've had other similar reports of the center ball losing its fluids. Interesting. Thank you, Patrick. Very good.
Thank you. Pleasure.
Thank you.
Well, that was very interesting. Here we go. Well, we're rounding up on 4 hours here and getting a little tired, but any other things to bring up? There's a couple of questions in the live stream. Mendel Jonkers was wondering if it would charge GANs water going through the Tesla turbine with, say, nano-coated copper disc plates, or create an actual plasma field. That's a great idea. I would like to actually try nano-coated copper plates. Problem with copper is that in a Tesla turbine you can't get the really high RPMs where the interesting things would take place, because copper stretches too easily, which was even a problem with the high tensile German silver steel that Tesla used. He was stretching plates because he always liked to push the limits like some of us do, and he stretched the limits of his turbines and stretched the plates, and they would get out of balance and sometimes totally disintegrate. And it could create a plasma field though, with the copper plates at a lower than extremely high RPM, especially nano-coated copper. And what it would definitely do is nano-coated copper plates in a Tesla turbine. Like you can imagine, if this was your Tesla turbine, these are nano-coated plates. You can inject it with your contaminated water. It would be broken up in the turbine action, as well as it passes nearby and on the plates, actually on a many feet of travel on the way to the center. That whole travel distance would be decontaminating the fluid, the water supply, let's say, or it might be converting other metals that might convert radioactivity as well. So that's definitely an interesting concept there. And it could charge GANs water going through the nano-coated copper disc plates. You could have a recirculating system where it just keeps flowing back through. The discharge goes back into some sort of reservoir where it gets pumped back through and so on. I've actually had a closed system like that for my experiments. So yeah, I think there's actually some work that could be done there with somebody that got into it heavily with the Tesla turbine, and it could be nano-coated copper plates, or it could be other types of materials as well. But the nano-coating could make a huge difference. Tesla would go nuts in today's society where you can choose the type of nano-coating on the plate. You'd really like that. Pontus Hasberger says, I would like to nano-coat stainless steel. I've tried NaOH and KOH, that's sodium hydroxide and potassium hydroxide, with no results. Any suggestions? Well, I know that that became a problem way back in the early days, a couple of years ago, when the reactors were being built by certain people. They would make a stainless steel reactor. Mr. Keshe was saying stainless steel is one of the hardest reactors to work with, and we were wondering why, because everybody was looking at these stainless steel bowls you could get that were half hemispherical shape to them, and they were fairly easy to bolt two of them together and fairly easy to rotate them on bearings, and you've got a reactor. And nice stainless steel, what would be wrong with that? Well, the problem is, of course, that the stainless steel the plasma, if you were to get your plasma created in that time we were working with gases in the reactors, not GANs, but gases. Hydrogen, helium, neon, argon, and so on. Soon's a really rare gas. Neon, so on, argon. what happened was people were trying this, but Mr. Keshe said that it won't work because the plasma will tend to seek out and be dispersed by the steel, stainless steel, bare metal physicality interaction. So what some people did was to copper plate the stainless steel. And there's a process, a fairly easy process that you can go through to do that. Once you have a copper plating on the stainless steel, then you can nano-coat the copper plating in the usual way. Otherwise, I think that for stainless steel it may be possible to use a strong acid in order to etch it, essentially, to make it rust, basically. Even though it's called stainless steel, certain extreme conditions will still cause it to form an oxide. Well, it forms an oxide anyway, as all things do, but it just doesn't appear to our eyes to form an oxide. But it could form one that appears to our eyes, perhaps using an acid. And what comes to mind, actually, let me show you my nano-coated stainless. I have an example here of a thoroughly nano-coated stainless vessel, which is this pot. You see the black coating on it. That is virtually impossible to get off. Scrubbies won't take it off. It's got burned in by some sort of it was a fruit mixture. It was sort of sugary, and it got burned in really good. And that was a couple of months ago with daily scrubbings. And that is one tough nano coating. I've encountered that before with stainless. It's perfectly good for everything except when there's high heat and sugars. So, that's a big clue. You might be able to nano coat your stainless steel with heat plus sugar, and that'll give at least a carbon nano coating, if not a steel itself nano coating. And there is carbon in the steel as well, so maybe that will tend to come out more when the sugar is added. Anyway, anything else that anyone would like to add or subtract at this point in time? I have to get wrapping things up here.
I put that unit in my truck, man. It's really nice.
Oh yeah.
It's really nice. The feeling around it's really nice. I know it's going to take a while for it to, to really get the plasma.
Well, if it feels good to you, then basically, if the unit's not coating, then your plasma is definitely expanding and basically nano-coating your truck. It's you're embedding that feeling into your environment. If you feel good about your environment, then it responds back, and there's an interaction, right? So it's a start. If it didn't feel good, it probably wouldn't be such a great idea to run these things, I guess. Thank goodness they do feel good. It feels good to run reactors. It's always a fun. I'm looking forward to getting this guy going and getting them dialed in and spun up with a couple of other globes in there, similar to what we saw with Patrick and so on. And,
where did you get those globes at?
Well, these are at the Walmart, but you could get them also at craft stores now because they use them at Christmas. You can get them in two different qualities, you might say. One is the deluxe model of made to be in one of the snow globe kind of things, you know. It's got a
Yep.
nice seal around the bottom, and it's got instructions that come with it and so on. Seems to be exactly the same material. This one doesn't have the special O-ring. It's got a nice well-machined bottom to it, so it would probably hold liquid fine as far as not leaking. But it's a little, maybe a little lesser quality than the more deluxe one that's triple the price. These were 2 for $5. Pretty hard to beat for spears these days.
Can't beat that.
Like I say, they are thin. Like you can see, I can push it in there. But it's also, it's like they you know, advertise them as being unbreakable. They are flexible, which is could be an advantage or not advantage depending on how you look at it. But I figure
It'll be a lot of fun.
I think it's flexible enough to give its own self-centering under high RPM. So we'll see. We'll see next week. Stay tuned for next week's episode. While we torture test the new Magrav unit. Oh, I meant to say this was supposed to be set up this way so that the open side is against this and will be bolted onto that plate. And then it's totally enclosed other than a hole for liquids to come out at the bottom. I'll put a tube on there in case something explodes. And then I'm going to mount the whole thing similar to this one. This one here, which it's mounted on a pin in the middle here, so the whole rig can rotate. And then you can do experiments sideways while rotating this, and it gives a different effect inside with that central voidness that forms and so on. And plus you can aim it at your neighbors and do all kinds of fun things. Just kidding. No aiming at the neighbors. That's not polite. Oh well, maybe it is. It might help them to stop fighting or something like that. What an idea. That probably gets a few hundred people out there working on setting up their things to stop the neighbors from fighting. Maybe that'll work for world wars. Okay, I think we better wrap things up here. I'm getting giddy. Starting to not make sense. It's been fun. I'm missing a couple other comments here. When you made caramel sauce, Rick, was that the nano-coating? No, it wasn't caramel sauce. I don't make caramel sauce. It was what do you call it? Mangoes. I was warming up a mango and maple syrup together, and boy, that's sticky stuff when it burns down and almost takes the bottom out of the pot. I've had that happen before with the aluminum clad stainless, where the aluminum stays on the stove top melting away while the stainless goes red hot. Yeah. Okay, enough about stories like that. Happy nano-coating, and we'll see everybody next week, next time around. Thank you everybody for coming by. I didn't ask if anyone had other things to show, and maybe there were some people that were a little shy this time around to show things, like maybe Libby had something that she wanted to show, but we can save it for next time, I guess. You have to get your elbows in here and speak up when the action is happening. I think I'm done for now, so let's end it for now and carry on next week. Okay, that's it for Keshe Plasma Reactor Group for what's now Wednesday, November 9th, 2016. And it's Rick Crammon signing out. I'll end the live stream.